Well, good afternoon, everybody. It is really an honor and a privilege to be with you here today. Before we begin, though, I do want to acknowledge that we are all devastated by the tragedy in Lewiston, Maine. Our hearts are with the victims, their loved ones, the community, and the first responders and caregivers who are treating those who were injured. We need gun control. I think we all feel that way. Well, so we're all part of a very special community, one that envisions a day when the world is free from the burden of cancer. This community has carried forward Dr. Sidney Farber's philosophy. Dr. Farber was a passionate pioneer. He was ahead of his time. He was relentless in his pursuit of cures. And he turned conventional medical wisdom on its head. And he was unfazed by the criticism of many other physicians for using toxic treatments in children with acute leukemia. And he insisted that, yes, these children may suffer from the toxicity, but 100% of them will die if we don't do something. And so he absolutely was innovative, and he said it's necessary to stop so many children from dying. So over 75 years later, we have incredible momentum to build upon in advancing key initiatives that promise to change the future of cancer care. The number of cancer survivors, and this is an interesting thing, in the US has grown from further than 5 million in 1980 to more than 18 million and counting today. But we can't be complacent because cancer trends do demand a new approach to care. 40% of all of us will develop cancer in our lifetime. 1 out of every 2 men, 1 out of every 3 women. And 20% of that number will die. And even more alarming is that the rate of cancer diagnosis in people who are under the age of 50 is increasing and has been increasing over the last decade. We are seeing more and more instances of seemingly healthy 30-year-olds who come to us with advanced cases of colorectal cancer. Dana-Farber is 100% committed to driving these numbers down through our research while also meeting the increased needs. In fact, in the past year alone, Dana-Farber served over 92,000 patients. That's an increase of 14%. So over the next few minutes, I just want to reflect on some milestones from the past year that I am most proud of, progress that, let me tell you, we could not have accomplished without all of you. You are phenomenal. You are our phenomenal community of supporters. And the Dana-Farber campaign is one of the largest and most important campaigns in cancer history. So this will set the stage for an unprecedented ensuing conversation with some of our executive leadership team to talk about where are we headed together and how are we going to collectively meet our ambitions, which are very large ambitions. In the past year, we have indeed passed some incredible historic milestones. A recent research study led by Dana-Farber's Chief Clinical Access and Equity Officer, Chris Lathan, demonstrated an incredible reduction in the time needed to diagnose cancer for medically underserved populations from 32 days to 12 days in a co-location partnership program that he funded. We've also seen 10% of the patients in this program go ahead and enroll in clinical trials, and that has doubled now the historical rate of 5% for marginalized populations. And we have an enormous number of brilliant faculty who do research, which we call our exceptional expertise. They are a pillar of the Dana-Farber campaign. They continue to deliver from bench to bedside and back to the bench again, with many of our faculty receiving top accolades and awards from renowned institutions. In fact, Dana-Farber investigators have contributed to the development of 35 of the 75 cancer drugs approved by the FDA for use in cancer patients. And we have more than 1,100 clinical trials that we can offer at Dana-Farber, which is very important because for 20% of our patients, the best opportunity for them, the best option, is a cancer trial. And we have one of the largest cancer trial programs in the nation. So for reference, this is more than twice the number of clinical trials conducted each year at Mass General Cancer Center. This includes clinical trials that have now led to multiple novel treatments, such as an antibody drug conjugate therapy for metastatic HR-positive, HER2-negative breast cancer. We also have a next-generation treatment for patients with relapsed chronic lymphocytic leukemia or small lymphocytic lymphoma. And last year, for the first time in 20 years, we delivered treatment advances for one of the worst cancers that we can experience, and that is previously incurable glioblastomas. A phase 3 clinical trial doubled progression-free survival and gave new hope to patients. And then in another clinical trial, previously untreated patients had the progression of advanced kidney cancer significantly slowed down by a 3-drug immunotherapy combination. So these are just some of the examples that illustrate that the need is clear and the time is now for cancer research and care to reach new levels. We must continue to attract and retain the best talent. We have to fund our scientists and allow them to explore new ideas that could lead to the next breakthrough, and to build relationships that will allow us to expand access to care in medically vulnerable communities. This pace of discovery and progress is really unprecedented, and we have much more to do to overcome a number of significant challenges in cancer medicine. We need to find solutions for every single patient that we see. And as we look ahead to the future of cancer care, the Dana-Farber Beth Israel Deaconess Cancer Collaboration, we believe, is going to truly transform oncology for our patients. Pending regulatory approval, this agreement includes plans for a new Dana-Farber-owned and operated inpatient adult cancer dedicated only to cancer hospital. And this will be the only freestanding inpatient cancer hospital in New England. And you are going to hear more about this exciting new collaboration during the panel in just a few moments. As we convene together, and I'm so delighted to have all of you here, this is a moment of opportunity. It's a moment of urgency that the entire Institute is rallying behind. And because of that, it is fitting to have members of my executive leadership team, which is unparalleled from any executive leadership team, to join us now. for a conversation about our community and your impact. So let me invite Lisa, Bill, Goldie, and Melanie. Can you please come up and join me on the stage? Okay, well, all of you, thank you so much for agreeing to do this and joining me in what is going to be a very important conversation. So, in the interest of time, I'm going to ask you just to share your name and role at Dana-Farber. And audience members, please note, they do have impressive biographies, and you can access them in the program book. So, Lisa, let's start with you.
I'm Lisa Diller. I'm a pediatric oncologist and vice chair of the Department of Pediatric Oncology.
Hi, I'm Bill Hahn. I'm a medical oncologist, the William Rosenberg Professor of Medicine, and when I wear my other hat, I'm the Chief Operating Officer.
I'm Goldie Taylor, and I'm Senior Vice President, Chief Communications and Marketing Officer.
And I'm Melanie Duvall, and I'm the Senior Vice President and Chief Philanthropy Officer.
Great, thank you all. And I'm very eager for this conversation. Draw back the curtain and share an inside look at what we are prioritizing now across the Institute and why we continue to believe that our community brings us together and pushes us forward. So, Lisa, let's start with you. Okay. So we all know Dr. Sidney Farber and the Institute's historical roots are in pediatrics. 75 years later, what do you see as the greatest areas of programs in pediatric oncology? And what do you think are still the most important challenges that we still have and we're still working to overcome?
Sure. I mean, thanks for starting with kids, where it all started. And those of you who've walked across the PMC bridge between buildings at the Dana-Farber, if you look toward Children's Hospital and the Brigham, you see a building there. That's the Jimmy Fund building. And I look across at that window sometimes, and I'm told, it's before my time, that Dr. Farber's lab was right up there, and that's where he sort of came up with the idea of giving certain drugs to cure leukemia, like you said, drugs that, other people were scared that they were too toxic for children. And that was really the beginning. And so I think the greatest accomplishment is chemotherapy, oddly enough. I mean, it's just kind of, what we did to cure childhood cancer was take what Dr. Farber did and build on it. How we give chemotherapy, how we give it with other chemotherapies, how we give it in combination with radiation, how we give it safely in hospitals where we provide, in the hospital, in Boston Children's, where we provide family-centered care and safe care. Learning how to do that over the decades has resulted in unbelievable cure rates in childhood cancer. You mentioned sort of the beginnings of childhood leukemia. I don't know how my predecessors did it. They went to the emergency room and they saw a child with leukemia and they said, there's nothing we can do. And now we teach our fellows when they go to the emergency room and see a new child who's diagnosed with ALL, childhood leukemia, and if they have the standard risk of ALL, their chance of being cured, a lifetime free of leukemia, is about 90%. And that's just building on all those chemotherapies that we gave. So where are we with challenge? There was a recent New York Times piece that was beautifully titled. It takes a lifetime to cure childhood cancer.
Yes.
So what we learned over the years is you can cure kids with cancer, but they're left with deficits. They don't return to the same life that they would have had. And that's our challenge now, and has been our challenge for some time. How do we get rid of some of the most toxic therapies? How do we reduce the need for radiation, which can be so harmful to children? How do we protect children from the side effects that they could develop? And how do we take care of our survivors like we do in the preemie clinic so that they approach the rest of their lives with the best quality of life possible? We've made tremendous inroads in terms of preserving fertility, protecting against heart disease, those sorts of things. And then the next step is going to be getting rid of chemotherapy. I don't know how, I don't know when, but that's my goal. One will be early detection and prevention. Somehow we're going to figure out who those kids are who are going to develop cancer and find it before it becomes life-threatening. Another way is kind of taking what my scientific colleagues, my colleagues in the lab at the Dana-Farber and other places are learning about the genetic drivers of childhood cancer and turning that around. And then teaching the immune system to get rid of cancer itself, manipulating the child's immune system so that the cancer is taken care of by the child's immune system. That's going to be the breakthrough, and we're going to do it.
Wow.
So that includes CAR T cells.
Yes,
for
that's
sure,
right. CAR
and
T
we
cells,
have-
manipulating the immune system is CAR T cells. Yeah.
And we have recruited several wonderful faculty that are focused on CAR T cells, and that's very important.
Really excited about
But,
that.
you know, we have to widen our reach to make sure that we're bringing all that's best for medically underserved kids. And you might want to say a word about some of the information and that Dr. Bona has identified when she looks at outcomes for children.
You know, as we've gotten better and better at treating some of our cancers, if you then look at who are we not curing, what we find is that actually social determinants of health is the term, but basically poverty is one of the biggest risk factors for not surviving leukemia. Well, what do we do about that? You know, and that's what Dr. Bona is dedicated to figuring out. You know, one of the things I love about Dana-Farber is that we have a resource program for parents. They never have to go without heat in their homes, and they don't go homeless. But we need to be able to figure out how to provide that more globally, nationally, understand why it works or if it works, to change that factor as a risk factor for not surviving cancer.
Okay. Bill, I'm going to ask you to talk about expanding Dana-Farber's reach and impact. Can you speak about the power and the advantages of collaboration and partnership in helping us achieve our vision of a world without cancer?
You know, I think there's a romantic image of the lone researcher late at night working away and making the breakthrough discovery. And I think that happened several times in the history of science, but it isn't really what happens today. 50 years ago, that was probably more common. Today, science and research is a team sport. People work as groups in labs, but more importantly, the tremendous progress over the last decade and a half has been because basic scientists, translational scientists, clinical trialists, and a whole village of people come together to work on taking discoveries from the bench and translating it into therapies that are actually useful in patients. And that collaborative spirit of science, I think, has been part of Dana-Farber for a very long time, and I think it's a part of the fabric. At the same time, our entire way we take care of patients and their families is built around collaboration. You have doctors who have very different expertise. You have nurses, navigators, clinical assistants, social workers, everyone working together to deliver multidisciplinary care. And it's almost impossible for us to think about how we would deliver care without that sort of collaboration. And it's quite a bit more complex from an operational point of view, as I've learned over the last few years, but it's absolutely the fabric of how we think about caring for patients. Importantly, I think collaboration really extends beyond our buildings. We collaborate with people around town and around the world. You know, sometimes the joke is if you want to see your colleagues, you will probably run into them at the airport. And the reason for that, and after COVID it's come back, the reason for that is that we are collaborating both nationally and internationally to push cancer science faster, but also to extend the impact of what we learn at Dana-Farber around the world. And it's a lot of traveling, but there's nothing that replaces those face-to-face interactions. In town, we've had great collaborations with many institutions, and as Laurie mentioned, we're really excited about our new collaboration with BI Deaconess that will create a cancer-specific hospital as the centerpiece. But it's an opportunity for us to think about what is cancer care and what is cancer research going to be in the future, and to create an even more seamless connection between the lab and the clinic and all the different types of physicians and nurses and others who care for cancer patients.
So, I'm not done with you. You may or may not know that Bill Hahn is not only a great scientist, but we convinced him to be our COO a few years ago, and he's done a fantastic job. And in terms of all of the negotiations and discussions we had with Beth Israel Medical Center, Bill was really the leader of that. So I want you to talk a little bit more about this new collaboration.
Well, you know, one of the great things about Dana-Farber is that we spend a lot of time thinking about how we'd like to do things even better, and what does the future hold, and how could we think about things differently. And when we started to have discussions with our colleagues at the BI, what was really refreshing was they really shared our vision for the future, that we should build a cancer-specific hospital, that we should rethink how we organize ourselves to deliver care, how to make research seamless between institutions, and yet keep each of us as separate, independent institutions that have long-standing histories. And so I think looking forward, what's great about this collaboration, and you know, we're already deep into the work, is planning what the hospital is going to look like, thinking about how we're going to take the best of what each of us has done over the years, but also think about how do we change the way we traditionally organize ourselves so that the spectrum of what we do is covered from soup to nuts, but also how do we make it so that the care of patients is seamless? How do we have cardiologists and medical oncologists and surgeons and radiation oncologists working in a seamless way in the care of patients? And some of that will be uncomfortable. Change is always hard. But I think you don't get many opportunities to rebuild something or create something that is your vision for what the future is. And so I think this, ultimately, this collaboration will take us a long time to build, but it'll set us up for the next 75 years.
That's right. Well, Goldie, we were so fortunate to recruit you, I think almost 2 years ago.
Almost 2 years.
2 years. And Goldie has spent her career in marketing and communications and branding. And so, you know, I'm going to ask you, you know, what tangible steps are we doing right now to grow our brand now? And why is this work is so important?
Thank you for the question. You know, I think, as Bill said, we really are in a very unique and rare, at this front edge of a very unique and rare opportunity, that we're truly at an inflection point as an institution, a time to transform how cancer is treated, both here and around the world. That's exciting for someone like me. That's one heck of a story to be able to go out and tell. But our focuses run around 4 pillars in our department. We're here to position Dana-Farber as the providers of choice, the partners of choice, the employer of choice, and the investment of choice. If I can win on those 4, that's the ball game. And so that's where we're pointed as a department every single day. But when we look for our true north, that North Star, what drives us, our story is our patients. We're a patient-first institution. It's how we were built. It is what will take us into the next 75 years. And those stories of children, of families, you know, of moms, you know, who didn't think they'd be able to have children, but gosh, now there are 3 because of the work of physicians and scientists here at Dana-Farber. If I can tell that story across this service footprint, but across the nation and around the world, continue to tell stories like that, that will help me hit those 4 pillars. Because that art of story is transformative, it's healing, it's unifying, and it's the kind of fuel and energy that we need to push ourselves forward. And so it is a great and grand opportunity to be a part of such an incredible part of this institution's history and to work in a room full of heroes every day.
You started to touch on this. I think Dana-Farber is quite well known, but share a little bit more with us of your messaging strategy.
You know, if you begin with the patient first, then you talk about the notion of, you know, we've said in the, with our partnership with BIDMC that ours is a patient-first model that takes you a lot of places. That says that everything we do around this patient is cancer, it's oncology care, everything in the building, from the person who parks your car, you know, to the nurse who comes, you know, by with your treatments. That's where our messaging begins, but it gets deeper than that. You've got to build proof points and story and data and sound for, you know, our executives to carry out and our other ambassadors to carry out to the broader world. And so our executives, as some of actually everyone here on this stage knows, we don't let them leave the door without having a fully fleshed executive briefing document that has crisp messaging, that has our story baked in, that has, you know, facts and figures about where they're going and what their objectives ought to be when they get there and come back. That really helped us fuel this launch. Our ability to do that for pulling together this announcement, it took months in the planning, really to get it done. And we didn't know, you know, how this would all turn out. But the day they said, we've signed it, our team sprang into action with the very messaging that Bill and others around our executive team had worked on and honed over the course of weeks. And now as we're reading the coverage, that messaging is coming back to us. It's resonating with our variety of audiences. That's when you know it's working, when you start to hear it coming back to you in the loop. Brand is what someone believes about you when you're not in the room. When Dana-Farber isn't in the room, we want everyone to know that all we do is cancer, and our patients are first.
Thank you, Goldie. So Melanie, Steve discussed earlier, I mean, this year marks our 75th anniversary of the Jimmy Fund, which, thanks to our incredible philanthropic community that continues to push ahead discovery for our researchers and, you know, spark discovery for all of our patients everywhere. And now, again, we were lucky to get you, to recruit you. It's been 5 years, I think. Coming up. So we're now in year 7 of the Dana-Farber campaign. What do you think makes our philanthropic community so special? And how do you see this community continuing to grow over the next 75 years?
That's a great question, and I just want to start by saying 2 things. We never follow a patient story, and I will never follow Goldie Taylor on a patient. I couldn't agree more with your last statement, Goldie. And again, welcome. I just wanted to, you know, I've been in this, I used to be the youngest one in the room, and now I'm not. I've been in this profession for almost, actually over 3 decades, which seems like a long time to me, and I love it. Every day, it's a wonderful, wonderful opportunity to come to work and, you know, either in virtual work or at Dana-Farber and be surrounded by such an incredible community of supporters. And one of the things that is so unique about Dana-Farber is that Dana-Farber and the spirit and culture of philanthropy started between Sidney Farber and Mary Lasker have grown up and out together. And so there is no daylight between this incredible organization that is Dana-Farber and the culture of philanthropy and this incredible spirit of support that is Dana-Farber. The Dana-Farber community is like nothing else that I've ever seen in any of my professional experiences. And it starts with the Jimmy Fund, and it starts with walking and golfing and riding a bike. And the PMC is this enormous, wonderful community that has supported us for over 40 years. And when we think about the campaign, we think about in the campaign for Dana-Farber so far, and we have about a year to go, almost 2.2 million gifts have been received. And that's an incredible community of support. This last year alone, 226,000 donors, unique donors, made gifts to support our patients. Our faculty that are in the room today, our community of donors is like nothing else that I have ever seen anywhere. And it's amazing, amazing. And thank you for being part of that. So to finish the second part of your question, where do I see the Dana-Farber community going in the next 75 years? I like to think like Goldie, that we have a story to tell, that we have opportunities for people to engage at every level, in every way, locally, regionally, around the world. And so far, we have donors in every state across the country and in 70 other countries. So we have a base of support that we can talk with and about. And in my mind, and I think this is something that's shared in the comments that you heard today, research has no boundaries. Research and care that is being done in collaboration with colleagues does not contain us to New England, does not contain us to Boston. So I'd like to think that in the next 75 years, we'll have Jimmy Fund walks all over the country, all over the world. Don't get me wrong, Jimmy Fund community, that is not the staff that are in the room in the Jimmy Fund community, that is not a to-do. Don't write that down. But I don't see any reason why we can't continue to grow and thrive as a community and to do more towards Lisa's goal of eradicating cancer for kids especially.
Very good. So you have 1 year left, and we expect a lot from you because you've already done so well so far.
A lot of all of us.
So, Melanie, I think you were going to
Okay,
ask me something.
Yeah, I wanted to ask you, Laurie, of all the things that are top of mind and important and a priority for you, given what we've just talked about, what is the one thing that you're really excited about as we look ahead?
I have to say that it is early detection and early therapeutics. About a third of our patients come to us with stage 1 cancer, and we can pretty much cure all those patients. But 2/3 of our patients come in and they've already had some metastasis, so they're not in stage 1, they're in stage 2 or 3 or 4, and it's harder to successfully treat them. But I think this is the future. Really, it's the future, because if we can detect cancer at an early stage, then we can cure it. So we need to have 100% of our patients in stage 1. So how are we going to do that? Well, there are many new things out there. Prevention, for example, high-risk people, like, unfortunately, as you get older, the biggest risk for developing cancer is getting older, and we're all getting older. And instead of doesn't look like this anymore, with a lot of young people in the bottom, and then our senior people, including me, up here. Now it looks like this, right? So we have had a major increase in people who live longer, which is great, but it does increase risk. And patients who've already had one cancer are very susceptible to getting a second cancer. So and people who have lifestyles that are not ideal, smokers, obesity, etc., also at high risk. So we have to identify high-risk individuals and follow them very, very closely. And so to do that, we have launched 5 different centers. I'll give you an example of one of them, and that is the young adult onset of colorectal cancer, which is headed by Jeff Meyerhard and Kimi Eng. Because, as I said earlier, it's just incredible that we are seeing these young, healthy-looking young men and women who come to us, and they come to us after they've already metastasized, because nobody thinks that somebody who's 30 years old is going to get colorectal cancer. We also know about mutations, genetic mutations, that we now follow. For example, Sapna Singhal has established the Lynch Syndrome Center. And Lynch syndrome actually occurs in 1 out of every 284 people. This is not small. And these are individuals who, if you have any of these 5 mutations, you have quite an increased risk of developing colorectal cancer, pancreatic cancer, or uterine cancer. And so what Sapna has done is, when a patient comes in with colorectal cancer, we sequence to see if that person has these mutations. If so, Sapna brings in, the uncles and aunts and cousins and brothers and sisters and test them so that we can find it early. Now, nobody loves to have colonoscopies, but it's a lot better to have colonoscopies every 6 months rather than come to us with metastatic colorectal cancer. And there's more on BRCA1 and the effect of BRCA1 on ovarian cancer and breast cancer. We have some very exciting new ideas and actually discoveries for how we can detect early ovarian cancer. And this is by Dipanjan Chowdhury, who has identified a microRNA that tells you that you have a person who is highly likely to soon develop ovarian cancer. So we've got to do it early. And that, to me, is the future. That's really the future of cancer, because if we can do this successfully, cancer is going to go away. We're going to be able to treat it. Okay, let's see, we're down to 8 minutes, so I think we should, we can do one thing. We can look at the 4 of you and tell us one thing, okay? So if you look at the year ahead, what is one initiative in your respective area that you feel is going to have the greatest impact on cancer? Lisa.
Well, I'm so excited about a new recruit we have in our department. He is an expert in CAR T cells for pediatric solid tumors that are, very difficult or even incurable, like high-risk neuroblastoma, which is very hard to cure, and DIPG, which is extremely difficult, if not considered incurable in children. And he has ideas and ways to manipulate T cells in order to make them sort of act against those cancers. And the recruitment of Robbie Maisner from Stanford to here is just an enormous move forward, not only for the Dana-Farber, but for the field, because I feel like he came to a place where he has all the things in place, the colleagues, the clinicians, the infrastructure for clinical trials, the relationship with Boston Children's Hospital, the laboratory bench depth, to really be able to do this. So I'm so excited, and a year from now, I'll update you.
Very good. And I have to say that a number of very elite cancer centers wanted to recruit Dr. Masner. UCSF, MSK, MD Anderson, but Robbie wanted to come to Dana-Farber. That's where he wanted to be. Bill.
Well, mine's obvious. We have to get organized and get our building approved and build the collaboration and really get both the literal and figurative foundation built.
That's a lot of work. Mine would be, my first day coming into Dana-Farber, Steve Singer, who used to sit in the seat, gave me an incredible tour of the Institute. And I said to Steve, there's an unmistakable feeling of hope in these halls. I don't know where it could be coming from, but here it is. And I said, it seems to me that people come here to Boston, to Dana-Farber, because they know if there's an answer, that answer is here at Dana-Farber. I want that to be true for the people who live around the world as much as I want it to be true for the people who live a stone's throw away. The life expectancy between people living in Dorchester and people living in Beacon Hill is astoundingly large. I want to spend the next year, and they're here in the room. Magnolia Contreras is here, Ian Matthew Clayton is here, Chris Latham is here, and others. I want to spend the next year figuring out, because it isn't the science, it isn't the clinical care, it's early intervention. It's letting people know what to look out for. It's getting them connected with their primary care physician, the number one indicator of late-stage intervention of cancer is lack of access to a primary care physician. And so our job is to get the word out. And so I'm going to give them the resources that they're going to need to tell that story. That's my next year.
Melanie.
And I think as we were talking about this, there are so many initiatives that the Dana-Farber campaign has funded. And while it's tempting to sit here and talk about one specific initiative that's like calling your first, your favorite child, your favorite pet, your favorite sibling. And so what I'd like to focus on is the momentum of the Dana-Farber campaign. And our campaign chair and vice chair are in the room today, our incredible philanthropy team, and our partners of faculty, research, our leadership. Without the combination of all of those things and our trustees, we will not be able to do what we have done. And we have so much momentum going into the final year of the campaign. I'm so excited about the opportunity to fund the things that Goldie's talked about, to lay down a plan for a potential new hospital building that, again, 5 years after Sidney Farber treated his first patients, he had built the Jimmy Fund building. And so to think about the opportunity to really advance the campaign in its final year with tremendous momentum and set us up for the success that follows is what I think I'm going to be focused on and excited about every single day.
And now we've left you 3 minutes to ask some questions. Anybody want to ask a question? I can't really see with the lights. Yes. Bob.
Laurie, over many years, you have talked about the importance of unrestricted funds. And buildings are important, elevators are, cafeterias, research is. And I'd like you to explain why it is so important to have unrestricted funds for progress and quick progress, and what you do with them.
Sure. It is really vital for us to have unrestricted funds because you never know what brilliant discovery is going to be made by one of our scientists or something new in treatment of our patients. And so this gives us the ability to say, okay, this is a top priority right now. You've discovered this. We need to push this hard because this could lead to cures of patients with X number of cancers. And so that allows us to say, okay, we know right now there are 3 things that are really important to us, and we need to fund those individuals now so that they can continue their discoveries. So it's absolutely, I can't stress enough how important it is to have unrestricted funds that we can then give to the people that are going to really make the big discoveries. Okay, anybody else? All right. Well, I thought this was an incredible. Oh, we have somebody?
We have a question here.
Okay.
Let's see. Okay. I just wanted to give a chance to answer the one concern that somebody could have when you move from a general hospital to the specialist cancer. A lot of us, if we're in the hospital, we've got other problems that deal with, be it kidney, heart, spine, and such. Will you be able to, I know you'll have people with maybe more experience with cancer and those problems, but will you be able to recruit and have the appropriate care for some of the more general issues that many of us have in a specialist hospital? So, thank you.
Absolutely. And I think what is not been made clear enough is that Beth Israel is an outstanding hospital. They have brilliant surgeons. They have non-cancer medical diseases, and they're going to be right there. We're going to have a bridge right over Brookline Avenue, and we'll be right next to Beth Israel Deaconess. So this is not really different in that sense from what we've always had with the Brigham. So you do not need to worry about that. We have this all set out. And Bill, you might want to emphasize that.
Yeah, as Laurie says, and if there are any regulators in the room, hopefully they'll agree that we will have these bridges that connect across the Brookline Avenue, as well as connecting directly into the Beth Israel Medical Hospital, as well as their surgical hospital. And although we will have a cancer-specific hospital, there will be the free flow of experts from the Beth Israel into our hospital, and we're actually going to go over into their hospital as well, because there will be patients who are in the hospital for a different reason and are found to have a new cancer or an issue with an existing cancer, and they'll call on us to come over and help them with those cases. So this is really going to be a collaboration and a partnership with an outstanding general hospital.
Okay. All right, Debbie.
Debbie first, and I just have to say, you blow me away. This has been so helpful and so reassuring at a time when there's a lot of stuff going on in the world. And one was today that, this terrible thing, and actually our granddaughter is a student at Bates. So, I know. In Lewiston. I'm sorry. And also, we still have this terrible problem in a part of the world that a lot of us worry a lot about, which is Israel and the Palestinian state. So it's wonderful to have community and come together and talk about something very positive, which is the future for Dana-Farber. So having said that, I will sort of end with a question. We get a lot of calls, I'm sure a lot of people here in this room do, and I think the answer to your question about who is going to take care of the other parts of our medical needs if we have cancer and you're in Dana-Farber's incredible new facility, our own hospital. Doesn't it, can you answer? Because people also, all they want to know is they have a doctor, and that doctor's at the Brigham, and they want to feel clear about, can that doctor still be their doctor? And I think the answer is yes, but I would love for you to confirm that.
Our patients can choose whatever hospital they want to be part of. It's fine. This is all about our patients. That's what it is about. They come first. And our patients select physicians, surgeons, et cetera, that they feel most comfortable with. And that's just fine. That's just fine. And you may want to.
You know, I talked to someone recently, and they had cancer, and they have physicians at Dana-Farber, physicians at the Brigham, and they were thinking through. They told me about their thought process. They were initially a little bit anxious about it, but then they thought about it, and they said, you know, my endocrinologist is at the Beth Israel, my OBGYN is at this hospital, and it's all worked out over the time, and it really isn't a problem. And I can tell you as a physician, and all the physicians in the room can tell you that we are working with physicians all over the state and all over the country to care for patients. And it really doesn't matter who their doctors are. We'll work with them, we'll communicate with them. And I think over time, people will see the relations they have with physicians will continue to be those relationships. And then we'll have new relationships with other physicians who come into our orbit. And so, you know, I think this is how we practice medicine, and it's how we've always practiced oncology. And so I don't think patients will see a difference in how their care is delivered.
I mean, we are so lucky in Boston to have several top-notch academic medical centers, whether it's MGH, the Brigham, Beth Israel, Deaconess, Boston Children's. There's nothing like it anywhere else in the world that what we have, and we should be grateful for that. Okay, so thank you all very much.
Pleasure.
And I thought that was a good conversation. Thank you all. And you'll, in the remainder of today's program, you're going to hear more and more about what we're doing at Dana-Farber. So thank you very much.
Thanks, Laurie. Thank you, Laurie, and thank you, panelists. I was thinking when Lisa and Bill were talking about, you know, sort of 50 years ago, actually 75 years ago, when people were walking the hallways at night, Sidney Farber, it turns out, was a real nocturnal creature. So he would finish his day here. He'd walk home to his house on Amory Street, close by in Brookline, have dinner with his family, which was a big deal. His family has told me, and then come back. And it was in the nighttime that he did his wandering of the tunnels and hallways. And the biochemist who gave him the drug in 1947 that resulted in the first child having at least a transient response of their leukemia was another nocturnal character. And they really had interesting histories. Sidney supported himself during medical school playing a violin. Yella Subro, the biochemist from India, supported himself getting his PhD emptying bedpans at the Brigham. But the two of them met during the night, and it changed the face of, and really sort of introduced the era of chemotherapy and the first use of single drugs to make things happen. So it's a long history. And Sidney, this was 75 years ago. Sidney died exactly 50 years ago in 1973. And at the time he died, he was around to see a disease that had been 100% fatal, the most common childhood leukemia, being cured in about one child out of 5. And as Lisa told you today, in that disease, that number is close to 90%, and for some groups of kids, 100%. So it's really been a dramatic change since 1973. And sort of the bookend on this that I get a kick out of because I sit next to him on Wednesday afternoons in clinic is the physician who's taking over this part of the childhood leukemia program was born in 1973. So we have continuity in place. He's treating our kids with immunotherapies that you heard about. It's a whole new world. So let me help direct you to the next really exciting 2 sessions. These are the breakouts. The breakout rooms are immediately on the other side of this wall. The first one on the left is the one entitled Artificial Intelligence is Here. What does that mean for patients? And Ellie Van Allen is going to head that one up. That should be fascinating. And then the next breakout room, just down the hall from it, it must be, if that's the artificial intelligence, the real intelligence room is going to be called Accelerating Drug Development and Improving Patient Outcomes. And Eric Fisher and Kathy Wu are going to be chairing that. So those sessions will run about an hour. We'll come back here. We'll have another panel at the end. And I'll see you in an hour's time or so. So thank you very much.
Thank you for attending this breakout session. It's a privilege to be here and a great opportunity to share some of the exciting ongoing stuff happening in artificial intelligence at Dana-Farber, and also present a vision for what we'd like to do going forward and how we'd like to engage with you all in this room in the same vein with which we engage with all the folks at the Farber across the institution to do this kind of research writ large. So as a way of sort of initial formal introduction, my name is Ellie Van Allen. I'm a medical oncologist in the genitourinary cancer division led by Dr. Tony Shueri, who's in this room. And I'm also the chief of a division called Population Sciences at Dana-Farber, as well as an associate professor at Harvard Medical School. And I've been tasked with sort of the provocative title of Artificial Intelligence is Here, What Does It Mean for Patients? And I thought what I would do before jumping into the topic at the forefront is actually rewind a little bit, explain how folks like me ended up sort of in positions to tell you all about this, and then lead you into sort of where things are at and where we think things can go in the future. So by way of a sort of a slightly less formal introduction, so again, I'm Ellie, and there's a picture of me. This is actually from 4th grade. I'm from Los Angeles originally. This was me out in elementary school, and I remember very vividly being extremely bored as a student in elementary school up until a very pivotal day in 4th grade when they brought an Apple IIe computer and put it into our classroom. I immediately gravitated towards it and very quickly realized that this was an incredible thing that I could use for a variety of purposes. Fast forward a bit later, I ended up going to college, still in California, at Stanford, and I studied something called symbolic systems, which is a mix of computer science with philosophy and linguistics. And this is a very tried and true career path or sort of degree program, albeit a bit of an odd one to explain to my parents, but a very tried and true one for one very specific career trajectory, which is going into technology, staying in Silicon Valley, and sort of harnessing both the sort of sophisticated quantitative skills that I learned and marrying that with sort of the emerging space of tech. And that was my plan. But a funny thing happened along the way. While I was in college, some friends approached me to help start a nonprofit. And this was something they were interested in doing, basically to help kids whose parents have cancer. And that sounded like a great thing, and I'll be perfectly honest with you. I sort of wanted to help them in part because I wanted to learn how you build something from nothing. And I would use that in my future career as a technology entrepreneur. And that actually turned into something called Camp Kesem. It's a camp for kids whose parents have or had cancer. We created the first camp at Stanford in 2001. We served 37 kids and their families. It was a sort of a remarkable success as a camp, and there's now, I'm very proud to say, over 150 camps across the United States, serving thousands and thousands of people, families dealing with cancer. And for me, on a very personal note, it was sort of resulted in sort of a humanitarian awakening and an opportunity to say, well, maybe I should actually think about taking my talents and my interests as effectively a computer geek and marrying that with oncology and seeing what kind of science and what kind of advances I could pursue in that domain. And so fast forward some numbers of years later, I find myself sort of at the forefront of an exciting new space in cancer research. I was and am still a clinician. I see patients every Monday morning on the 11th floor of the Yaki building at Dana-Farber. I was and am still a computer nerd, and I like to write code and solve puzzles using the data from the patients that I treat. And I've been able to merge that with the world of biology as applied to cancer and use this sort of confluence of different spaces together to understand sort of this disease and use it to find new drugs for patients. And in this sense, this field, clinical computational oncology, lets me sample the patients directly. So the patient is my model system that I get to study, the patients I care for. I get to write code and come up with algorithms and figure out ways to sort of solve the puzzles that are inherent in the patients that end up developing cancer, why they become resistant, and so on and so forth, and merge that with cancer biology again and put that right in the middle. And this is sort of the field that I'm in and the space scientifically that I operate in. But it can still feel a little abstract. And I think for the purposes of this presentation, which has a somewhat daunting title, artificial intelligence is itself sort of a daunting sort of set of words, I thought I'd actually zoom it down into a patient, a motivating patient that really explains sort of the motivation for why we're doing this. This is actually a patient I started caring for as a first-year medical oncology fellow with Dr. Choueiri, way back when, I think this was like 2011 or so. This is a patient with metastatic kidney cancer. This is a CT scan, and you don't need to, there's no test, there's no exam at the end of this session, but I'll just want to tell you that this is sort of part of the abdomen, and this big red circle here is encircling something that's not supposed to be there. This is a metastatic deposit from a patient's kidney cancer. This patient had already progressed on, at the time, really the only FDA-approved therapy for these patients at that time, and the life expectancy was 0 to 3 months. We were able to get this patient onto an early phase trial of an emerging cancer immunotherapy, and was very happy to see that this patient achieved a complete and durable response. And this patient effectively has been cured of a metastatic solid tumor, in this case a kidney cancer, which is something that as a first-year medical oncology fellow, I really had a tough time wrapping my head around, but how truly remarkable that was and how amazing that still is today. So that really also provoked a series of very interesting questions and thoughts I would have about what does this all mean? You know, what is the biology? What are the genomics? What's the explanation for why we see this in some patients and don't see this in others? How do we actually evaluate and figure out who should get these drugs in the clinic? You know, who is this for? And, you know, who is it not for? And how does that all work? And then, in addition, and I think this was really nicely articulated by Goldie earlier in the prior session, how do we make sure we get this for everyone? And so these three questions, sort of why, for whom do we do this, and how, are really at the heart of really all the science we do. And the overarching theme and sort of the question really for this session is whether there's artificial intelligence can actually help promote this and help push this forward across the board. So with that as sort of a backdrop, what I thought I would do is really explain to you a couple of examples of how this motivating patient and this patient's story has prompted some initial forays into using AI for some of these questions, and then I'll end with, you know, some visions of where we want to take this before I open this up for questions. So first, AI for biological discovery. Why? Why does this happen? Why did that exceptional response happen for that patient and not for other patients? What we've done over the last 10 years in the field is basically try to study the genomes of these tumors and sort of scan every part of the genetic code and look for patterns in these genomes and figure out whether there are differences in the patients who respond from those who don't. And that's a question we wanted to apply to this particular patient and the many hundreds and thousands of patients like this patient, where we sequence these patients' genomes, and we wanted to ask which ones respond and which ones don't. There's massive amounts of data that one has to deal with in trying to answer that type of question. And there have been many folks in the field, in the community, who have developed algorithms to try to parse through that data, sift through this huge haystack to find the needle. And it would take me the next 3 or 4 hours to go through all of them in detail. But I'll just say those have worked to a degree, and we have developed and used some of those over the last 10 years ourselves. But increasingly, there's this opportunity to take some of these newer algorithms, these sort of deep learning algorithms that are parts of AI, and place those at the center of this question. Take this huge amounts of genomic data, train these AI algorithms, these deep learning models, these neural networks. These are some terms you may have read about in various domains. Have it figure out what are the patterns that discriminate those who respond, like my patient, and those from those who don't, and use that as a way for discovery. But there's one big problem with those kinds of algorithms, or at least one big problem, that are often sort of depicted in these kinds of cartoons, is that those tend to be black boxes. We can't answer why. It can't tell us what was it in the genome that actually explained this particular response. And that leaves those of us sort of on the biological side wanting for more. We're sort of saying, well, that's not really satisfying. We can't intervene upon something we don't understand, and we need to understand why. So we took that actually as a challenge that might even be a challenge that could be solved with some creative computation. And so we took the same concept of neural networks that I just showed you in the prior slide, and instead of sort of leaving it as it was, we engineered biology into the network. So what does that mean? That means instead of each of these little nodes and edges that connect the nodes that are used to train these deep learning models, to train these algorithms, we actually had it model what we know and what has been discovered over the last 100 years of biology to represent genes and how genes are connected to each other to create pathways, and how pathways are connected to create processes. And in doing this, we've engineered sort of all that is known about biology into the architecture of the model, and we can then use this to not only figure out sort of which patients are likely to be different than the others, but also open up the box and figure out why. And in this case, we were able to do this, train the algorithm on the same genomes that I told you about a moment ago, have it figure out which ones are, patients are likely to respond and which ones for patients not likely to respond. Open up the box, discover a new gene we had not expected, but was actually relevant for treating these kinds of patients, that is immediately translated into repurposing a drug that was being tested in a completely unrelated use case into the use cases we cared about, and have launched a phase 1 clinical trial. And we did this without generating a single new genome, but rather collecting all of the data that already exists in this domain. And sort of even in this toy example, demonstrated how we can use biologically informed AI with experimental biology that I'm sort of skipping over for the purposes of this presentation, and take that straight into a clinical trial that we can now do at Dana-Farber. So that's one quick example of AI for biological discovery, AI to help us understand why. But we also need to use AI to figure out for whom, right? And so here's another really exciting place where AI has a major potential impact for patients with cancer. And for this, I'll actually sort of harken back to that picture I showed you before, the CT scan with the big red circle that shows you where the cancer is, and say this is actually a picture. And as it happens in medicine, we have a lot of pictures from a lot of different sources. And this is from radiology pictures, but we also have pathology pictures. When we take tumors out of patients, they get sliced up, and expert pathologists look at them under the microscope. They help us make diagnoses, and they are effectively, as sort of was alluded to earlier in the open session, human intelligence. Humans trained to predict and figure out what kinds of cancers are where and how bad they are, looking at features in a picture. So why am I telling you this in an AI session? Well, outside of cancer, pictures are also being used to drive a lot of the innovation in AI. Think of self-driving cars. That is a picture challenge. The car needs to figure out where the people are, where the other cars are, where the street lights are, and so on and so forth. And these are problems for which many AI algorithms have already been developed and are now being deployed. I was just in San Francisco a couple weekends ago and had a chance to take a self-driving car instead of an Uber on my way to a wedding, sort of to give you an illustration of where that technology is. So how can we take that into cancer? Well, we can take these pictures from our cancer patients, and in this case, this is a kidney cancer, similar to the patient that I described to you earlier. This is a picture of the cancer under the microscope. Train AI algorithms to figure out not just where the cancer is, but what different features there are within the cancer, and how those features can actually create more complex, but still quantifiable, meaning complex, but still things we can measure with numbers, and be able to compare across patients. Map not just the stuff about the tumor, but also features about the immune cells that surround the tumor, and use combinations of these things to successfully predict which patients are most likely to benefit from that same immunotherapy I described to you earlier. Not from a huge amount of genomics and not from a massive amounts of all sorts of different things, but simply from a picture. That's pretty cool. So so I told you about a biology example, I showed you about a clinical implementation example. What about AI safety and equity? How do we actually make this sort of available to everyone? How do we study the problems that could arise with AI? And here too, our community has really been leading the way in thinking through this. This includes examples from our group, where in our case, we actually took an algorithm that was built by Google and tested it on thousands and thousands of cancer genomes to figure out and demonstrate that it actually worked better for finding some of the events that we care about for patients who are likely to have inherited cancers, sort of like some of the cancers that was alluded to earlier in the earlier session, the folks that Sapna Singhal and others treat in their early intervention programs, and for which we actually were able to report not too long ago in JAMA. And it also means coming up with ways to think about this technology from an ethical perspective, and in this case, engaging with their ethics research program at Dana-Farber, and sort of bringing the ethicists into the fold early and often to make sure that this new technology is developed in a way that's applicable and relevant to everyone. So I hope I've sort of impressed upon you the first sort of bit of this, that we think there's a huge opportunity here to understand why for biological discovery, to figure out for whom for clinical evaluation, and how are we going to give this technology to everyone. But the fun part about this is, and sort of as you can probably imagine, sort of as a computer nerd who accidentally went to medical school, I can sort of recognize that we're just barely scratching the surface of what is possible in this domain, and why this represents such an exciting time, both in the science and in the clinical aspects of what this could mean for cancer patients here and everywhere. So what do I mean? Well, there's a few good examples. So here's one example. You may have heard about some of these things called foundation models. These are things that are being used in lots of other domains and are getting a lot of attention in the press. ChatGPT, DALL-E, DeepMind. I don't know if have folks heard of any of these? I see some noddings of head and raising of hands, fantastic. Just in case you haven't, I'll give you an example of what this is actually doing. So this is for ChatGPT. Basically, this is an AI algorithm trained on trillions of words and letters and paragraphs and documents and everything you could possibly imagine, that is then sort of used for two kinds of purposes. One, to help you sort of validate things and to help you ask it questions to make sure that there are things that you might know. So here's just one example that I used it for not too long ago, just as out of a curiosity. I asked it a question. I said, what's the initial treatment for grade 3B follicular lymphoma with lymph nodes above and below the diaphragm? This may or may not have been a board renewal question that I was doing in real time. I'm a genitourinary oncologist. I cannot confess to taking care of too many lymphoma patients these days. And sure enough, ChatGPT gave me a very reasonable and thoughtful answer. It also can do some pretty cool things on sort of helping you creatively think through potential unseen concepts. So this is a harder one to sort of wrap your head around, but when you have something trained on trillions and trillions of words, curious things can happen. And there's too many ways to articulate this, but I thought that maybe the most approachable way would be the way I approached it to my wife, who's not in medicine, but my wife is also a former professional tennis player. And so I said, come over here, check this out, this is cool. She's like, why? I don't want to get it. I said, my wife is a tennis player and also a big Britney Spears fan. I said, can you write a song in the style of Britney Spears about the top 5 men's single tennis players? And she's like, sure, okay. And for those of you who've used this thing before, it's within about like half of a second, it just spit out an entire song. And it was like dead silence for my wife and just jaw on the floor. Pretty cool, right? So why am I telling you this? Well, in cancer biology, there are certain domains for which we are approaching scenarios where we too have trillions of measurements that we could conceivably secure. So before I showed you some of our genome work, where we're taking tumors and we're studying their genomes as sort of one unit, what now folks at Dana-Farber, ourselves, many others are doing is studying single cells. So sort of taking the tumor, spreading it out, measuring individual cells within the tumor, and measuring lots of different things within those cells. And so you could imagine that creates orders of magnitude more data, which starts to approach, we're not there yet, but it starts to approach the kinds of data that things like ChatGPT was trained on. Which then opens you, if you start to use your imagination, can let you think about all sorts of cool things you could do that would not otherwise be possible under any circumstances. You can validate existing concepts. So, as a postdoctoral fellow with my mentor Levi Garraway when he was still at the Farber, we thought a lot about a signaling pathway in cancer, and you can query this kind of a foundation model for cancer biology and make sure that it actually represents things we expect. In this case, there may be a few drug targets that some folks may recall if you follow the nuance or not. But the far more provocative thing that this could conceivably do is actually help us explore the vast amount of unknown biology, the things that are not in the architecture we already know, which I had told you about earlier, which really only represents 3,000 to 4,000 genes, if I'm being generous, of the 20,000. We don't really know a whole lot about many of the others. We don't even know where to begin with many of the others. And can something complex like this help us come up with new hypotheses that might help inform new drug targets, new ways of thinking about the biology across the board? And that's where we have this potentially profound opportunity for biological discovery, for drug development, and using high-dimensional, very complicated data with these novel AI approaches to completely revolutionize everything we know about cancer. So that's for why. What about for whom? Well, we have an opportunity as an integrated hospital at Dana-Farber to do some really creative things in this domain as well. We could, for instance, take all the genomics we're currently generating from patients and try to match it using algorithms developed by our friends in the data sciences department, Ethan Sarami and others, called MatchMiner, to figure out which trials might be most relevant for a patient based off of their genomic profile. Match that with the information in the electronic health record, where you have little bots sort of constantly trolling the electronic health record to figure out when is a patient ready for a trial, and help doctors find these patients, those that have a match for a trial and actually need the trial, so that information can be given to the doctor in real time, which could rapidly accelerate sort of everything we do about trials and whatnot. This would be pretty cool, and I should say very concretely, this is already happening. We're doing this study now. This is being led by folks listed below, Ethan, Mike Hassett, Ken Keel, and others, across multiple departments at Dana-Farber, really across the entire institution. But this too is just the start, right? I showed you before the pictures that were used in that one N of 1 case. Well, couldn't we insert all of those kinds of pictures and radiology information and other kinds of molecular data into these models to make even better versions of these things? And couldn't we then come up with a whole series of clinical trials and clinical contexts to take those trials into, to study every which way AI could matter? That's actually the future, and that's where we could be going as a community. So why, for whom, and then how? How do we make sure that this kind of technology, which has its challenges, and I'm sure that will come up either here, and I'm having dinner with some of you later to talk about some of these things, how do we make sure this matters for everyone? And that's a major responsibility, because these kinds of technology really can be complicated. There have already been some pretty challenging issues with these approaches outside of oncology that have already happened and have been reported in the lay press. So how are we at the Farber thinking about tackling this head on? Well, one thing we need to make sure we do is that we need to make sure that the AI we're developing is not trained exclusively on a small set of patients treated at 450 Brookline Avenue. We can harness the Dana-Farber network and invest in collecting information across the entire Farber network that represents a far more diverse spectrum of patients, experiences, populations, rural and urban settings, and so on and so forth, and use this to train algorithms that are more equitable and representative. But it isn't just a local or even a regional problem, it's a national problem, and truly, it's an international problem. And so another thing we could do is actually invest in the similar kinds of collection across the world. We're lucky, sort of in my division, to have a Center for Global Health Equity led by Tim Rebick and Dio Fidelu, amongst others, who are thinking very deeply and have spent years and decades building trust in communities across the globe, largely third world countries, different kinds of healthcare systems. And we could invest in collecting that information in a similar way so that our AI is truly global. And it also means, perhaps a little provocatively, that were we in an opportunity, in a circumstance to be building a brand new hospital, hypothetically, we could make it AI enabled. So what does that mean? Well, that could mean everything from sort of intentionally building in sort of ways of making sure we have sort of constant measurements, so the right kinds of measurements for our patients in real time for care. It could even mean things, and they're sort of maybe a little bit pie in the sky at the moment, but not totally unreasonable, of thinking about our inpatient cell therapy experiences and how do we use combinations of things like AlphaFold for sort of the right kinds of protein engineering along with sort of novel ways of administration to then tailor drugs to patients in a truly personalized way that actually is equipped, that has a hospital actually built to do that. It's on the table. So why, for whom, and how? There's a huge amount of opportunity to do this. And the other cool thing, I should say, is that we at Dana-Farber are at the forefront of leading the charge. One of the most unexpected but joyous privileges I've had really in my career happened just a week ago. I had an opportunity to participate in a Senate briefing that was exclusively focused on AI and cancer. Unfortunately, this was a closed briefing, so we do not have fancy pictures, although thankfully that means I was not on C-SPAN, which was a relief, because that would have been a little bit, perhaps stressful. But over the course of an hour and a half, in an intimate environment, and you can't see them unless you're really good at making the backs of people's heads. Well, first of all, there's me. For a pretty large and really refreshingly bipartisan audience, you can maybe recognize your favorite or not favorite senator amongst the list. We were able to have a frank and honest discussion about cancer and AI, And I'll just say, I was the only oncologist in the room. There were folks from Google and folks from Tempus. There were the former NCI director, Ned Sharpless, who also was a former Dana-Farber fellow, was moderating it. But we had some really thoughtful engagement with a lot of the senators in the room who were very keen and recognized the opportunity therein. And in fact, amongst them, Chuck Schumer, who sort of wanted to say, he actually sort of impromptu went up to the podium to say a few words, which I guess is what politicians do, really sort of emphasized that, even from his perspective as somebody who obviously is not an expert in this domain, recognized the opportunity and said, we have to do this. We have to do this in a bipartisan and equitable way, and it's got to be for everyone. And so that's the goal. Biological discovery, all sorts of opportunities. I've kind of given you a little bit of flavor of some of the stuff that's happening. Clinical evaluation and equitable implementation. These are not siloed activities, as you might imagine, and because of the sort of the inherent team collaborative spirit of Dana-Farber, we're already thinking as groups on how we do this. This includes folks like myself, Dr. Schwery, Dr. Irizarry, who's in the room. I saw Dr. Kathy Burns, a pathologist, who's the department chair. Bill Lauder, who's a new recruit in data sciences, who actually built and sort of and then developed and sold his own mammography AI company before coming back to academia, and many others are thinking about how we do this together. Which is to say that Dana-Farber, of course, is uniquely positioned because of all of the things I mentioned to lead in each of these domains and push this as the future technology for the next 10 to 20 years and really revolutionizing care. So in the last few minutes, what do we need? Well, we need a lot of things. Because if I'm being perfectly honest with you, this stuff is hard to do, it's expensive, and it's the kind of thing that, and having just sat through another study section with a grant review panel with my friends at the NCI over in the federal government, it's not the kind of thing that is going to be sort of easily fundable from a traditional means. Because we need to do a lot of things. We need to recruit more faculty and staff. We're competing with for-profit industry, Google, Microsoft, and whatnot. And it turns out they have deep pockets and are willing to sort of pay some of the really talented scientists who can do this kind of work a lot of money. And we need to compete with them and bring them into our cancer world. We need to generate that data that I told you earlier to get to trillions and trillions of bits so that we can actually sort of build these models in the right way. And we need to figure out ways to generate compute that can actually handle this information, and so that we're not constantly, as happened to me this morning, getting kicked off of Google's cloud because somebody else, some other like for-profit monster is seeking it out. We need to invest in more clinical informatics. We're, obviously, as you heard with this new collaboration, have both sort of a challenge and an opportunity to revisit all of sort of the clinical informatics that is sort of part of our daily care that actually feeds these models. We need to invest in trialists who actually understand and want to take on the challenge of how to study AI in real life. And we need to figure out ways of investing in the regulation of these things. This sort of came out at the end of our Senate briefing, where it sort of was very clear that the subtext of that entire meeting was, amongst the senators and that whole sea of staffers that came with us, that they don't know what to do with this, and they're afraid to over and under-regulate this thing. And we need to be at the forefront of that and invest in sort of making sure that it is best suited to help our patients. And we need to make sure this is equitable. I sort of alluded to investments in data collection and whatnot in our networks across the globe. It's not cheap, and I think Dr. Glimcher alluded to a study from Chris Lathan, who's a member of Population Sciences, and actually demonstrated that especially for underrepresented minority populations and lower income populations, you need to invest in just sort of boots on the ground and people there to make sure patients stay in the clinics, and that data actually represents something and is meaningful. It's sort of as simple as that in some sense, but that stuff's expensive to do. And then to make sure that the technology that we are developing here is not only useful here. There's surely more things that need to be done, but I hope this is a flavor of the kinds of opportunities, challenges, and needs that we have as we think about sort of how we put this whole puzzle together as a community. So I think I have maybe about 5 minutes. Yes, okay. To open the door for questions. I'll also be here the whole rest of the day. I'm sure other folks in the room will be very happy to talk to you all as well. Thank you for attending. I hope this wasn't too daunting or intimidating for you all. And sincerely, thank you for all you do on behalf of cancer patients here. Appreciate it.
Thank you very much for this. It's amazing. Just the whole immunotherapy and TIL research is really important. My question is around training the models. So, you're on the Google platform, obviously regulations, compliance. How are you protecting patient data?
It's very important. And so your question is actually, if I can zoom back here, and one bipartisan question or concern that comes up, you can't see my mouse, from these folks, is very similar about patient protection, data privacy, and whatnot. We are very careful in ensuring that we're using sort of secure, compliant platforms for the training of these models to ensure that there is no leakage of personal information, which is of high risk, and that we are sort of following all the best practices. The good news is that we already have faced this challenge in the genomics era, because genomics is, in some sense, identifiable information. There are people who can hack genetic data and sort of reverse engineer it and figure out where you're from if that data is made publicly available. So we need to we basically can borrow those kinds of protections for things like this. That being said, we anticipate there will be a lot of challenges that come with rolling these kinds of technologies out, and which is why I was sort of coming back to the need for investments in effectively next generation informatics and regulation protection to ensure that we sort of keep things as secure as they need to be, and ensure that patient trust, which is paramount, we don't lose. That's a great question.
So how are you thinking about the application of this to early detection and prevention?
Great question. So we have a lot of initial forays and sort of experiments we're doing in this domain. Actually, I have a sort of a looming collaboration with Sapna Singhal, who's also a member of Population Sciences in my division. And so in that, as an example, I mentioned to you earlier the example of pictures, right? So another place where you get pictures is in those colonoscopies that we do for some of our patients with inherited genetic syndromes. That happens every 6 months, and it can be very hard to sort of scale that kind of screening technology and doing all the downstream pathology work on every single possible biopsy and whatnot. And so one thing we're thinking about doing is training some of the same kinds of computer vision algorithms, these AI algorithms, to sort of predict which of these lesions are really likely to be cancerous or even precancerous and which ones are benign, for instance, as an initial toy example in that domain. I think the bigger vision would be that, as the early detection and intervention initiative that you sort of was alluded to earlier today really starts to expand, that we're investing in a lot of the data collection elements so that we can more aggressively intervene and find patients earlier and earlier, perhaps even pre-cancer, pre-diagnosis, and sort of do the right kinds of intervention well in advance of how things usually happen. I think that, again, requires sort of a forward-thinking investment in the proper kinds of data collection over a long period of time to train the algorithms to do that kind of a task, but it's something we're very keen to do and excited to collaborate with Sapna and others on and doing. Pardon? Whoa, we're at time. I'm so sorry. I'm happy to take your question offline. Thank you again. I think we all have to head back over there. It's a privilege. Cheers.
It's my great privilege to welcome you all and talk about one of the topics that's very near and dear to my heart, but I think is also a central priority for Dana-Farber, and that is accelerating drug discovery. And I didn't pick the title for this breakout session, but I think it's a very fitting title for the two people you will hear from. My name is Eric Fischer. I'm the director of the chemical biology program at Dana-Farber and a professor in biological chemistry and molecular pharmacology. and Kathy Wu after me, who's going to speak about a different topic, but all ties together in drug discovery and accelerating drug discovery. I think I just want to spend 1 minute on giving kind of a broad overview. When we talk about accelerating, I think there are various ways we can do that. We can accelerate the process, we can accelerate the way we do clinical development, but I think we've just witnessed one of the greatest examples of acceleration in drug discovery, which is the development of the COVID vaccines, which are really, the reason we could accelerate it so much was that there was a new technology. And I think if you look back at the history of medicine, there have always been these inflection points when new technologies, new advances in therapeutic sciences were introduced that led to great acceleration or really expansion of scope. And I don't want to go through all of these examples, but I think one we can all relate to in the context of cancer treatment is the invention of therapeutic antibodies, now probably 3 decades ago, that really opened up an entire new area of therapies that are now a cornerstone of every treatment regimen. And similarly, in the space of small molecules, we've always had these advances where things changed, and I'm going to walk you through this a little bit. Let me just take one step back, and I think we've just heard about the importance of chemotherapy, and that's the traditional paradigm of treating cancer, where you have these rapidly dividing cells, and the basic principle of chemotherapy is that you have a toxic agent that is just a little more toxic for a cell that's rapidly dividing and can't cope with this additional stress. And that works fantastically well in many cases. We've just heard about the cure rates in pediatric. I have to say that children generally tend to deal with the toxic load a little better than adults, but it comes with side effects, it comes with limitations, and I think especially in the adult space, there's limits to efficacy with some really great exceptions, but it's clear that there are additional tools needed, and it's not necessarily going to replace it everywhere, but there are additional tools needed. And about 20 or 30 years ago, we had one of these steps where we really had an inflection, and that was the beginning of what I would consider really a paradigm shift, the start of targeted therapies. And I'm going to give you the most classical example, which is where the genome break creates a mutant protein called BCR-ABL, which is a kinase that's activated and really is the cause of these cancers. And it was the realization that there are these mutant proteins, and then the creation of molecules that specifically inhibit this kinase in this case. And now you have an agent that not is generally toxic to the body, and the cancer is a little more sensitive, but you have something that's specific to the cancer and that treats specifically the cancer. And we've seen a tremendous progress, and we continue to see new agents, but there are limits, and we always run up against these limits once we really start to exploit technologies. And while a kinase has this wonderful little pocket where you can fit in a small molecule and you can inhibit the activity of this kinase, we've now learned from another corner of really advances, sequencing, big genomics data, we understand the mutational landscape of all our patients, that not all causes or all contributors to cancer and other disease look like this. Many look rather like this. This is a transcription factor. And even without going into any detail of protein structure, you can probably recognize that one is much more disordered. It's a pile of spaghetti, as I would refer to, while the other is a very structured noodle. And one, I can imagine I can fit a small molecule in, but it's very hard to fit something that specifically binds and distinguishes one pile of spaghetti from another pile of spaghetti that sits next to it. And so we need new technologies. We can't really find molecules to bind to that specifically. But what if instead of doing so, we could just dispose of it? And so I'm going to give you one example of a relatively recent advance in therapeutic sciences where we've been able to do this, where we've been able to essentially devise molecules that act like one of these garbage trucks, take the disease-causing pile of spaghetti and throw it out into the bin. And the reason we can do that is because nature is always a step ahead. Nature has usually done what we're trying to do already millions of years ago, and nature has developed or evolved a system that's called the ubiquitin proteasome system, which can specifically target any protein in a cell and dispose of it by shuttling it to a big, what I would call the cellular garbage truck, called the proteasome, and it gets chopped up in little pieces into its amino acid constituents. And so about 20 years ago, people thought about, well, can we hijack the system? Can we make molecules that would tell the cell to take care of, for example, an oncogene product and just send it to the trash? And in fact, we can. And I'm not going to go into too much details here, but we can now make molecules such as the one shown here, which artificially recruit a specific protein to the cellular destruction machinery, lead to ubiquitination and degradation of this protein, and degrade it. And so this is great conceptually, and it's been around for 20 years, but it hasn't really gone to any therapeutics. And the reason is often because there's something else needed. There's a lot of skepticism, and rightfully so. Before you put something in a human, you need to cross a lot of bars. There are concerns, and when this first came up as an idea, I was back at Novartis, and people would tell me this is impossible, right? You can't do it. You can't just put a molecule in a patient that would degrade a protein. It has some toxicities. It turns out what you sometimes need is a lot of luck. And in this case, luck came from a very old molecule with a very unfortunate history, and that's this molecule on the left, which is called thalidomide. Was used in the 1950s, widely in Europe and some other countries to treat morning sickness, and unfortunately carried severe embryo toxicity, and so many, many children were born with severe birth defects. Obviously, it was withdrawn rapidly from the market. It's noteworthy it was never approved in the US, mostly due to the work of one woman at the FDA, Frances Kelsey, but it was rediscovered in the late 1990s to have activity against multiple myeloma and some other hematologic malignancies. And people didn't know why, but they started using it. And so now you had thousands of patients being treated with this, and it turned out to be highly efficacious in multiple myeloma. And 10 years later, several groups, several of those at Dana-Farber, including Ben Ebert, Bill Kalin, I was still back then in Switzerland, but we were all working on this problem, why do these molecules work? And it turns out it works exactly as this idea. It uses the ubiquitin proteasome system to degrade two transcription factors, Ikaros and Aiolos, that are those piles of spaghetti in a cell that are causative and for drivers of multiple myeloma, and degrading those two proteins can lead to curative outcomes. And so, well, not curative, but improved disease management. And so now you put the idea together with a serendipitous discovery of clinical proof of concept, and you get a real acceleration in the field, because now suddenly people will believe you that this can actually be done. It really expands the scope, because if you look at what classical inhibitors can do, it's a small sliver of the entire proteome, but drug targets are across the entire space. And so now it's not that targeted protein degradation can cover all of this, but I think the concept here is that expansion of therapeutic modalities, similar to what we've seen with antibodies, can really expand what we can do therapeutically. So how do we play into this? It's a complex problem, and this is just ignore the details here, but there are many, many parameters that we don't understand. It's a very novel concept, and when I came to Dana-Farber, I really set out to think about how can we make this accessible? Because if we make it accessible, people will play with it, and people will understand what can be done with it. And so we raised three main questions. One was, can we understand the targets that are amenable to this? Because it was obvious with antibodies, which are extracellular, and everything that's on the surface on a cell, you can target with an antibody. Everything that's within a cell, you can't. In this case, it wasn't that clear, and we developed tools to do so. Can we understand some of the principles, and can we make them widely available? And then we will have biopharma and academic centers pick them up and make new therapies. And can we precedent some targets that are either hard or have other hurdles, and again, encourage others or do it ourselves to develop new therapeutics? I was just going to give you very, very brief examples. One way we went about mapping or making targets tractable was that we just generally mapped the landscape. And this is a great example where we see just convergence of technologies, which is something else that's happening right now, and where we have high throughput genomics, proteomics technologies, we have better approaches to computational approaches, we have machine learning and other things that make large-scale initiatives possible. And it really boils down to we can learn some of the grammar that underlies degradability. So we can learn the grammar that defines whether a target is tractable to this approach or not. And we've done this over the last couple of years, and I think the best way I look at impact is not so much have we made a drug, it's have we inspired others to do that. And there's a great example of work that my then still Dana-Farber colleague, Nathaniel Gray, and I did early on, in the very early days, where we were working actually with a pharmaceutical company on trying to make degraders of KRAS. And this was a 3-year project, involved a lot of people and a lot of resources. It failed at that point. We didn't get where we wanted to be, but we said, we did do the groundwork, and it turns out this pharmaceutical company, along with some others, went on, and now we have clinical trials of some of these molecules in the clinic. And this is really where I think we make the greatest impact, that we take this initial step and we really try to show people the way, and at a stage where it's too risky for any larger company to take on. And we've worked on principles, and again, this is very basic work. So in this case, one of the things we did, we really tried to understand mechanistically and structurally how do these proteins interact, what are the rules, what are some of the principles there that govern this. And we published this, and people pick it up, and I have a lot of other groups reaching out to me asking about this, so I know it's been taken up by the community. And again, doing this enables a lot of, in this case, a lot of biotech companies out there working with these principles, and within the time frame of 5 or 6 years, this field has really exploded, and there are now, I think, in excess of 30 clinical trials with new degrader compounds in clinical development. This is kind of a representation where they are, and I have to say that a lot of those are not yet where I would really like them to be. They're not in novel targets, they're not in novel biology, because it's, again, there's this de-risking, and it takes more, having been within a larger pharma company for a little bit, to convince something to take something on with a lot of biological risk, a lot of modality risk. So you see people go into very established targets. And so one thing we've been thinking about is, can we again help? Can we precedent this? Can we go into new indications, new targets, and maybe we won't have the resources to go all the way, but can we show people the way? And this is another example. We've taken on one of the transcription factors, or one of these piles of spaghetti, in this case a transcription factor called Helios, which was discovered actually at Dana-Farber to stabilize the phenotype of regulatory T cells. And the hypothesis was that if you degrade Helios, you would unleash the immune system to attack the cancer. And it was impossible to do this with any other technology. So we worked again with Nathaniel Gray back then and made prototype molecules, leveraging the same system I've just shown you is in play with thalidomide, and actually leveraging the fact that these molecules really like transcription factors. And we thought if we would modify them and if we would make libraries, we might be able to target other transcription factors. And it turns out that's the case. So we were able to make, in this case, prototype molecules that worked in cells and worked in mice, but wouldn't work in humans, but demonstrated that you can target Helios, the transcription factor. And now there are clinical trials from Novartis that run with a molecule very similar to what we did, targeting Helios, and are currently in clinical exploration. I think what I've shown you is just some high-level vignettes, and this is just one example of new technologies in therapeutic sciences, and we really try to work as a team here. And we work as a team within Dana-Farber, but we also work broadly with the industry out there. There's several companies that came out of Dana-Farber that try to take on these technologies and take them the next step. We've done very innovative partnerships, such as the Center for Protein Degradation. We're constantly looking, how do we broaden our impact? How do we take things further? I should also say that I'm really passionate about the chemical biology program at Dana-Farber being really a team play, where we have currently 10 faculty within the chemical biology program, and one of the missions we see for ourselves is we partner broadly across the institute and outside of the institute and really try to bring together all the expertise from the clinical side, from the deep understanding of cancer biology to our chemical mindset to think about advancing therapeutic sciences and advancing novel therapies. I think I might even be a minute ahead of time here. So just left to thank a great team, great lab, many, many people, and obviously thank all of you for your support of what we do here and everything you do for Dana-Farber. And I introduce Kathy Wu to join me up here.
Great, wonderful. It's wonderful to be here. I think, so my name is Kathy Wu. I'm the chief of the Division of Stem Cell Transplant and Cellular Therapies at Dana-Farber and the Levine Chair for Preventative Cancer Therapies at Dana-Farber. And it's really a pleasure to be here. I think I'm going to be talking about something completely different than what Eric Fisher mentioned, but I think you'll see similar themes, namely the impact of advances in technology, what that has afforded us therapeutically. Also the theme of kind of our deep dive work to shine the path, to kind of inspire and motivate the field and try to transform the way that we think about therapeutics, and also the way that we kind of work together as teams. I think these are just kind of general themes despite the differences in subject matter that you'll hear. So now for something completely different, I'm going to talk about the immune system. So I think many of you are very familiar with what this system does. I will just briefly summarize to say that this is our army of defense that distinguishes between self and non-self. This is our first line of defense between external pathogens and invaders, and it involves every single organ in our body. There are many different types of immune cells that are key to coordinating together a strong immune response, but first and foremost, I will mention that T cells play a front row job in this whole system. And in terms of what are those external pathogens, our immune system is hardwired to recognize bacteria, fungi, viruses, parasites. These are kind of, they come in all shapes and sizes and flavors, and our immune system is really hardwired to deal with this heterogeneity and diversity. And a critical function of what T cells do is that they search and destroy. So in this kind of image on the bottom left is a T cell that encounters a cancer cell, and you can see successively as you go to the right, it kind of recognizes and goes to town, destroys. And this kind of critical function of T cells is really predicated on recognizing peptides that are on the surface of a cancer cell, which we call antigens. So these are kind of the recognition units that the T cells see. So how do it's long been a hope that we could mobilize this very essential function of T cells to help eradicate cancer. But first, just a little bit more about kind of core functions of what T cells do. So again, they check for pathogens and mount a response against them. Our immune cells are constantly surveying in our skin, in our nose, in our mucosal surfaces, and if they encounter a pathogen, they start to move and they go to the lymph nodes and they start to coordinate in a coordinated response the generation of more cells and antibodies so that we can address that infection. And the other critical function of what T cells do is that they create memory. So they remember what was previously encountered. So what this graph shows is that if you have a first infection, yep, it takes a bit of time to mount a response, but if you come against that same the set of peptides, those antigens from those viruses or bacteria or whatnot, then the response is very fast and of greater amplitude. So this is what we call immunologic memory. And we've seen examples of these type of core functions at play over and over again. So this is an example that I like to use, which is a count that occurred on the Faroe Islands, which is up by Scandinavia. There was a measles outbreak back in 1781. Then there was no measles for 65 years, but then there was another outbreak in 1846. Those infected in 1781 were not infected again. So this gives you, were not infected again in the second outbreak in 1846. So this tells you that there is long-lasting immunologic protection if you gain that immunologic memory. Now, in more recent memory, for better or for worse, we know about COVID. And I think we will agree that the vaccines are basically what helped get us out of the lockdowns and all the trouble that we were in a number of years ago. And this was this idea that if we can give prophylactic vaccines, will that help us generate the antibodies or T cells that we need to protect us from subsequent infection? So now what about cancer? Well, cancer, for better or for worse, we are often talking about the situation of therapeutic vaccines. So these are our patients already have cancer. How do we mount a T cell response? How can we increase the breadth and the diversity of those tumor-recognizing T cells so that we can actually eliminate cancer? That's different than the infectious disease setting where we're trying to prevent. Now, for cancer, we hope to get to prevention. It's just that we still need some time to get there. For now, we're really dealing with therapeutic vaccines, but I do think that there are instances that we hope that we can get to prevention, and Dr. Glimcher mentioned some of the different centers that we're generating so that we can start to think of preventative strategies. I do think that the rapid advances that we made in the COVID vaccine were helped by the decades of work that was already underway in cancer vaccines, and that helped feed forward and pay it forward to the rapid deployment of the COVID vaccines. But I do hope that now we're at a time that we can take the lessons learned from the pandemic so we can really make an impact on our cancer vaccines. Now, and this overall, I would say, just in terms of cancer vaccines, our general schema of how we think about how cancer vaccines could help us is that if the vaccines are there to expand and broaden the repertoire, could we not partner that together with immune checkpoint blockades like Keytruda, other agents that are currently being used in the clinic that can help release the brakes? There's adjuvants that we can use to rapidly accelerate the response, but can we not use the vaccines to help steer the response to recognize those antigens in the direction of anti-tumor, where we're not actually impacting normal tissue, so low toxicity, but high efficacy to actually get us closer to cancer cure. Cancer vaccines is not a new concept. It's been around the block. So what has changed? What's different now? And this is what Eric had alluded to, new technological innovations that have really given us the leaps to move forward. And I still remember this, a decade ago, when these two articles came out in the New England Journal back to back, and this was some of the early clinical trials that told us that immune checkpoint blockade antibodies could really create dramatic clinical responses for solid tumors. We have in the audience one of my laboratory neighbors and colleagues, Dr. Gordon Friedman, who was one of the initial discoverers of this really critical axis. But I think it's just been incredible how basic discoveries about the circuitry and the wiring of the immune system has led to such a huge impact in our field, such that cancer immunotherapy is another pillar of therapy. And I'd like to kind of akin the discovery of these immune checkpoint blockades to I call it the Obi-Wan Kenobi moment, where kind of, that goes, moo, and suddenly the shield kind of goes down. So suddenly this vulnerability was there for cancer that allowed us to kind of move in. And to me, this is a little bit what the immune checkpoint blockade antibodies have done. The second huge innovation, also about 10 years ago plus, is the availability of relatively affordable and high throughput DNA sequencing. This is a graph that is very well storied among academic communities that study genomics, where large efforts such as the Human Genome Project and the Cancer Genome Projects have kind of sequenced all of these different tumors and try to look at kind of the mutation rate and burden across cancers. And what I would say that for me, this is a little bit like, wow, okay, so now that we can do sequencing, is this going to give us an opportunity to find those antigen, find those targets so that the shield is down, let's kind of go in. And so in the same way that sequencing has been really transformative in revealing to us on a population basis, but also on an individual basis, those mutations that drive those tumors, it has also opened up a therapeutic opportunity because some of those mutations, if you kind of go from left to right, as the DNA mutations have the potential to change the sequence that then create amino acids. So the peptides begin to change. Some of those peptides will have the ability to bind to what we call HLA. This is kind of the ticket to get to the surface of the tumor cell. And once those peptides are on the surface, there's the potential for T cells to recognize them. So I mentioned before the antigen. So now you have tumor-specific antigens that the T cells can go over. And so I like to call these antigens, we call them neoantigens because they're not in normal cells. And I would say they kind of hit the sweet spot because by virtue of coming from the mutations are part and parcel of a cancer cell, they are very tumor specific. And at the same time, because they're recent events, they're coming from the cancer, the body has not been trained to dampen down immune responses against them. So they're highly immunogenic in the same way that a bug, that a bacteria, that a virus would be. So that's the sweet spot, this upper top right. And this is really a different place than where the field had been before sequencing became available, which is kind of in that big gray area where the field was really thinking about expression and shared across individuals as a way to target. So now with sequencing, suddenly there is this concept that, oh, neoantigens that have been theoretically thought to be interesting, well now we can build computational algorithms that allow us from the sequencing data to integrate that with not only DNA but RNA information, but we also have machine learning algorithms that have been trained to allow us to predict what are those peptides that could mount a T cell response. So you put all that information together and out you go. You have a set of antigen sequences that are predicted to be highly immunogenic per individual. And this is also an important concept because what we have known and learned from our technological innovation of sequencing is that cancer is not the same from one individual to individual. In fact, what we've learned is that each individual has a quite unique and different tumor. And so how do you deal with that heterogeneity? It's not one size fits all. Can we now, with sequencing, now that we know the set of neoantigens per individual, can we then specifically target that individual cancer, get to the cancer, don't touch normal tissue, and are we on our way to developing better immunotherapies? So at the outset, our group was really focused on building kind of the computational pipelines that would allow us to make these predictions. And our next question is, can we actually translate this to our patients? Can we actually build personal cancer vaccines and give them safely and efficaciously to our patient? And our group was among the first worldwide to generate a proof of concept clinical trial in melanoma. This could have really only happened here where we had such a deep infrastructure for generating investigator-initiated clinical trials. We had the surgeons, we had the way to collect samples, we had the way to bring it into our cell processing lab, we had the way to predict those peptides and then to bring it back to our patients. And that the concept is shown here. We in real time sequenced our patient tumors. From those predictions, we were able to generate peptides that we pooled into 4 different pools, and we gave them as injections to our patients. And we gave them in what we call a prime boost schedule. We were trying to mimic what we think happens in a viral infection. So lots of early antigenic exposure up front with the prime, and then 2 boosts to stimulate immunologic memory. And some of our results were really immensely gratifying. We had 2 patients here, patient 2 and patient 6, who both had recurrent disease. But if you think back to that cartoon schema that I showed you, where we thought about, can we give the vaccine together with that immune checkpoint blockade? In fact, that's what happened with these 2 patients. They got the vaccine, then they got anti-PD-1 treatment, and within 12 months, 12 weeks, both patients had all of those lesions melt away, and we are now 4 or 5 years out later without any disease nor on any therapy. So certainly this has been a signal of hope for us to kind of, and positivity to kind of continue on this path. We've also had the opportunity to work with David Reardon on glioblastoma. I don't think for this audience I need to go into what a challenging setting that is. In our field, we call it a cold tumor, meaning like as opposed to hot and inflamed, where T cells are really not getting up there. So our question was, could our vaccine actually help get T cells, our soldiers, to where it's needed? And so we devised a clinical trial here, only possible at Dana-Farber because of our incredible infrastructure, where at the time of surgical resection, that gave us the tumor cells to go and sequence and then to predict and then manufacture and bring together a personalized vaccine that we gave when the patients finished their radiotherapy. And I'm happy to say that we were able, the colors here show you in the yellow and the green, those are 2 different flavors of T cells, and certainly before and after the vaccine, we can see increased numbers of T cells that were able to get into this otherwise cold tumor. So I want to say in the last couple slides, I wanted to kind of show a little bit of how do we think forward in terms of how do we design our program. And it is really kind of an integrated program of discovery, but also feeding forward to clinical trials and back again. And so I've told you a little bit of 2 of our trials. We are focused on target discovery. We are focused on vaccine formulation and administration. And it is critical for us to understand the impact of the work we do. So we also do a lot of immune assessment. And so this has, this sort of kind of paradigm has allowed us to really, on the way left side, focus on disease-specific research. We have vaccine trials across many different tumors, and we do welcome the opportunity to get in deeper and understand better those malignancies so that we can do better with our vaccine strategies. I'm going to tell you briefly about our ongoing trials, and on the right-hand side, our approach to building new capabilities so we can maximize what we learn from our patients. And then, of course, taking all that information and feeding it forward again to think about the next iteration of trials. So first, what do we do in terms of our disease-specific research? Well, we really have been taking deep dives in the nature of those tumor-reactive T cells. These are, for better or for worse, relatively rare cells, so we have to have really great technologies that allow us to evaluate cells one by one. We are at a very interesting and exciting age of technological innovation, where now we are able to do single-cell analysis. And way on the left, these sort of single-cell analyses allow us to look into the phenotype of the cells. They also allow us to look at, for T cells, they express what we call the T cell receptor. It ends up being kind of a barcode, so we can actually figure out how one T cell, or what we call a clone, is related to another. We can look at the hierarchy of the response. And finally, we want to know, what are those T cells seeing? How is this all related? And if we can understand that, this certainly will lead us to understanding new targets, new vulnerabilities, new approaches. Second, what about our trials? As I mentioned, we have a very exciting portfolio of investigator-initiated trials across the different disease centers in melanoma, led by Patrick Ott, glioblastoma by David Reardon, renal cell carcinoma with Tony Chuari, ovarian with Panos Konstantinopoulos, in CLL with, in the blood malignancies with Inye An and Eric Jacobson. So I've been so fortunate to be able to partner with my clinical colleagues and really devise smart trials that ask different questions depending on those different disease settings. And I just want to have a teaser. This is a recent trial we just completed in renal cell carcinoma. And what's exciting about this trial is as routine patients get surgery, but then they get the vaccine. And what we've observed now, already 40 months out, is that no one has recurred. That is super exciting because this is a disease where, especially those with high risk, we do worry about relapse. In the right-hand curve, we did see one step down, and for better, unfortunately, this was due to mental illness related to COVID, but it was not related to disease. So I would say in the other patients, and so far we've treated 14, we have seen no recurrences, and we're really excited to see this type of approach go forward. In the last kind of bucket is kind of how do we think about new directions in kind of learning the most from our patients. And insofar as kind of understanding on an individual cell-by-cell basis, we're already starting to look spatially. So how are all these cells organized? How is their architecture in space? And we've been blessed to work with colleagues over at the Broad Institute in a technology which we call SlideSeq that allows us to get a tissue section on a slide, and then we're able to kind of computationally reconstruct kind of the architecture and look at the RNA level, the DNA level, and even the T cells and their clones. And so in my final slide, 2 slides, I just say, how are we getting to next vax? And this gets back to kind of my comments about COVID, which we've learned that, you know, how can we get there faster and at lower cost, and how do we expand the repertoire of antigen targets that we get to? I think that's where the next level of innovation is required. We are hard at work because faster time and lower cost will mean more patients that we can treat, and more patients that we can treat means that we can answer larger questions related to prevention. So I want to thank you for your attention. I think that we've really thought a lot about tumor antigens. How do they relate to other cells in the tumor milieu? That we are really thinking hard about the lessons we've learned from the pandemic so that we can get to efficacious, cost-effective vaccines. And there's a lot of exciting data, not only from us, but in the field about the promise of personalized cancer vaccines. And I'm happy to talk to any of you about this. And again, what Eric mentioned, we are so grateful for our Dana-Farber family, the teams that we work with, and I thank you for your attention and your support. I think I'd like to ask Eric to join us, and we're certainly open for some questions.
Transplant, like, and I'm one of the transplant people, where we receive T cells from a donor versus vaccines trying to activate, it seemed like trying to activate your own T cells. So
Yes.
I'm just repeating because
Yeah, so you're trying to figure out who, when we vaccinate, who are we kind of pulling to work? And I would say that in patients without transplant, yes, it is their own the patient's own T cells. In patients who have gone through transplant, it could be the donor cells. So we, actually I started my career thinking about vaccines after allogeneic stem cell transplant. And a lot of those principles helped me think through what we now have in our kind of non-transplant vaccine program. But vaccines can be given in many different settings. And because they're given as an injection, they will stimulate T cells whether they're coming endogenously or from allogeneic and grafted source. We had another question? Yeah.
I haven't taken biology since 9th grade, so. But the question that I have is that my late husband had a mutation. And the way it was described to us was, yes, we have a targeted therapy right now, but the tumor is going to get smart and it's going to outgrow, and it's going to get smart again. So I guess the question I have is that with all this innovation, all this research, all of the work that you're doing, these tumors are always going to be smart? I mean, is it a never-ending kind of, I mean, I'm being simplistic about it, but for a lay person, how do you make them stupid, I guess?
I would say, and you can chime in, if we only have one targeted therapy, the tumor is always going to get smart. The way to get there, and we actually learn a lot from infectious disease, is to have multiple targeted agents that are non-overlapping. So you're not targeting just one mutation, but you at the same time targeting another vulnerability of the tumor, and then maybe you activate the immune system. And once you have, I think, 3 to 4 threats to the tumor, it's going to be really hard for the tumor to outsmart you. But unfortunately, in some cases we are there, but in many cases we aren't there yet.
And this is not chemotherapy?
No.
Yeah, and I would add to that, which is that I think, what you're describing and others have described is like a game of whack-a-mole, right? So like you go, so I think it is a vote in confidence of synergistic combinations. And I would say that this kind of concept has informed us for how we design our vaccines, because we're not going against one antigen. We're trying to come in with 10 or 20. This is where cancer is also, a cancer vaccine is different than a COVID vaccine, because although there are some principles there that are similar. So I think, so not only kind of a complex vaccine, but also, I also mentioned combining it together with immune checkpoint blockade, like the Keytrudas, and even combining together with a targeted inhibitor, so that can actually shrink the amount of tumor that. So I think combinations are really what we're all thinking about.
This is really for both of you. Dr. Wu, you said during your presentation that this research could only happen at a place like Dana-Farber. And Dr. Fisher, you mentioned, I believe, that you had come from industry to Dana-Farber. Could each of you expand on what makes the research environment at Dana-Farber so unique as opposed to industry, or as opposed to collaboration across institutions or other cancer research hospitals?
Thank you for that question, and I'll start and Eric will follow, because I think we have different kind of experiences. But I would say, one of the things that is so special about Dana-Farber, and I kind of came through the system, I was trained through the system and stayed, is that I think there is a seamless kind of handshake between the clinical and the basic science. So what that means is that kind of the innovations can be born, but they can be implemented in a clinically informed and appropriate manner. And what that also means is that it's not easy to actually, we're unique, across different academic centers. It is hard to build the infrastructure that really makes beautiful, deep dive work possible. So what I'll say is the infrastructure to collect samples. So I don't know if Ted Pasquarello is here, but the Pasquarello Tissue Bank has been kind of really transformative for the way that we do our translational research. I think that having the cell therapy lab has also been incredible to support kind of actionable cell therapy, bringing it to the clinic. I think that the ready access to sequencing resources are innovative ways that we can apply to our patient samples so that we can understand is really imperative. And then the other thing is the depth of kind of expertise across all the different fields in our midst, in our environment, has really been incredible to make sure that we're going in the right direction and we're doing it in the best possible way.
Yeah, I think I have to give you two answers. One is personal, my personal preference. I think there's a lot of things the industry does really well, and we work with them in many levels, so I think that's to be stated. But I really think this innovation needs to happen, and it's something I believe my passion is, and that is hard in an industry environment often because there are much more constraints. There's always a commercial aspect, and often these innovations happen in small indications. They happen in something that's clearly defined, which may not be commercially viable, and so it's easier in an environment like Dana-Farber. And then I think the second point I want to make is what struck me and still strikes me every day at Dana-Farber is how much all of Dana-Farber is purpose and less politics. Having seen the industry environment, they're really great people, but there's a lot of structure and there's a lot of politics or things that need to happen that aren't necessarily following just the purpose of doing something and getting something done. And what's been amazing in coming to Dana-Farber is how you can assemble. I worked with people, and especially in the first couple of years, who may have not seen before. They're my colleagues, but it's a big place. And you're immediately on the topic. You immediately get people together, excited around an idea. And there's no, why should I do that? Is this going to help my division, or is it going to help a different division? There's a great idea. Let's run with it. Let's do it, and we'll figure out how to get there. And that's just, I think, something that makes Dana-Farber unique, probably also across academic centers. One more? Or?
Do you think you can combine your approaches with early detection when the tumor load is very, very low and maybe there's not as much diversity?
We always do better when tumor burden is low. So I think as a field we are evaluating how to bring together targeted approaches, immunologic approaches. The immune system is really great at mop-up function. So if you can get the tumor burden really low and do mop-up, that's going to give all that memory and long-term benefit. That sounds pretty good. So I think that certainly I think we've kind of given you two different, very different approaches, but really with the same goal that is actually quite synergistic. Thank you for your question. Okay. Thank you.
Welcome back to the stage, our MC, Dr. Steve Sally.
Thank you, everybody. I hope that the sessions on artificial intelligence, drug discovery, whetted your appetite. They're clearly what I think all of us in the room see as the now and near and far future both. The last of these panels today is it's called Driving Change for Our Patients. Those of us who have cared for patients at Dana-Farber recognize, had one of these conversations out in the hallway a few minutes ago too, there is something special about the care of our patients at Dana-Farber, and the people who know it best are not necessarily their caretakers, but it's the patients, and they'll tell you that every time. And I know in the course of being both a caretaker and an administrator at times, that in our lives, in the medical world, if you put the patient at the center of any potential problem or concern or weakness, if you work your way from the patient out, you always make the right decision. It's, you can't make these decisions for them. And I have to say, you know, having actually been a patient at this institution, I always thought maybe I got special treatment. But then I recognized from the people sitting next to me, nah, we're all in the same boat. So it's a pretty special place in that regard. And it's a pity you have to be a patient to know that, but I think those of you who support us in all these different ways know it either yourselves or through family members. So in this particular last session of the day, driving change for our patients, my long-term colleague is going to lead this, Barrett Rollins. Barrett was the Institute's first Chief Scientific Officer. He's the Lindy Professor at the medical school. And he broke the rule that I learned from one of my professors a long time ago, who said, you know, Salin, there's only two kinds of academics. There's those who read and those who write. And Barrett breaks the mold. Barrett is a reader and a writer and a clear thinker as well. We've been on lots of tables and committees and thinking about patients in the Institute. And one of the things I can tell you about Barrett Rollins is when the decision is made, it has an ethical, true north center and is highly likely to be the right choice when there is no real right choice. So Barrett, please come up. You can introduce your panel.
There we go. Is my mic on? Yeah, oh, God, it's on. Thank you very much, Steve. My mother would be very proud. So yeah, I have the privilege of leading this second panel discussion of the day, Driving Change for Our Patients. I don't know who came up with that title, but I do think it's a great title. And the reason I like it is because it captures one of Dana-Farber's core values, and that is all of us strive all the time to innovate in all sorts of ways to improve the lives of patients with cancer at our institution and around the world. And a lot of times, we're the only place that have come up with those ways of improving lives of patients. So for example, this is seen in the research side, where I think you've heard us talk over the years about our balanced portfolio, how we devote ourselves to doing 50% outstanding patient care and 50% cutting-edge research. And I will remind you that Dana-Farber is the only cancer center that has this as its goal. And I will also remind you that the only reason we can do this is because of generous donations from people like you. But we also innovate all the time in patient care, in particular around nursing care, because it's nursing care that first impacts our patients with cancer. And we also innovate around health equity, this idea of making sure that everyone with cancer, even individuals who are part of historically marginalized communities, get the benefit of the care and the research that we do in cancer. And so in today's panel, we actually have representatives from all three of these areas: research, nursing, and health equity. And so I would ask each of the panel members to introduce themselves, do the same deal we did with the last panel. Tell us who you are and what your role is at the Institute. Start with Tony.
I'm Tony Schwery. I'm a medical oncologist. I do exclusively GU tumor, genitourinary oncologist. I lead the division of 25 doctors, and also another hat, I'm the medical director of the business initiative at Dana-Farber.
Ann?
Good afternoon. I'm Ann Gross. I'm an oncology nurse and Senior Vice President for Patient Care Services and Chief Nursing Officer at Dana-Farber.
Karen Burns-White. I have the pleasure to work across the research consortium of Dana-Farber Harvard Cancer Center, where the work that I do helps to influence health equity as well as look for initiatives to reduce the unequal burden of cancer.
Thank you. It's wonderful. I feel very honored to be on the stage with you guys. I'm going to begin with Tony. So, clinical trials. Let's talk about clinical trials. To me, that's where the rubber really hits the road when we talk about how we're going to bring our science to patients and test whether or not our science actually is going to benefit them. So there are a bunch of different kinds of clinical trials. There are ones that are initiated by investigators. There are ones that are initiated by drug companies. Maybe you could take a few minutes and tell us about the various types of clinical trials and, importantly, how they're funded.
Well, yeah, thank you, Barrett. I mean, clinical trials is the way where these drugs that we develop or partner with us from the lab, take them and apply them to the patient, whether they're first in a human or at the second level, phase 2, or they're at the phase 3 studies where they are compared to what is the standard. So we beat the standard and move on. And that's why in the past 5 years, half of the drugs approved by the FDA came from Dana-Farber. So there are several ways to do it, but the most two common ways are the industry-sponsored trial. There's a drug owned by industry. They come to us. Usually these are, not exclusively, but usually these are larger studies that happen not just in the US, they're all international. The approval can happen and mostly happen in the US and spread other places. There are very, very complex, many of them led by Dana-Farber folks. They cost on average today hundreds of millions of dollars,
yes, yeah.
By the way. And sometimes one...
Just saying.
And 4, not anymore, but 4 out of 5, at least this is from a couple of years ago, fail. You know, because this is how, you know, when you apply it from animal to the first in a human to then a regular population, it fails. So that's one. Second, and we work on that. The second way is we take a drug. This is an investigator-sponsored study. We benefit from the consortium of the Dana-Farber Harvard Cancer Center that has multiple studies, usually are smaller, usually are heavy in science. For example, Dr. Van Allen and I collaborated now for more than 10 years where we do the trial, we do the biopsies, we take the tissue and the blood, it goes to Ellie's lab, and we do some of the most innovative things that in many situations the industry is not doing. They have, you know, no idea about. And we take it to the next level. It's smaller. Sometimes it's funded. It's funded by pharma sometimes in a way, but it's us who leads it. That's in general the two ways to do it, and the cooperative groups studies, which is in the middle in a way, and mostly in the United States.
So I love that sort of note of shock and surprise when you said pharma's funding these. You know, great. Thank you, Tony. So let me move on to a related question to Anne. So Dana-Farber is justifiably known for the quality of its nursing. But one of the things that people may not know is that nursing is not just one thing. There are many, many different types of nurses at Dana-Farber, different kinds of training, different kinds of responsibilities. Maybe you could tell us a little bit about what the spectrum of nursing at Dana-Farber is really about.
Sure, be happy to do that. Well, you know, I'll just start. Nurses in general were trained in a holistic model to focus on health promotion, healing, and ensuring quality of life for patients no matter where we encounter them. And so you can imagine, it's not surprising that at a place like Dana-Farber, no matter where you go in the institute as a patient, you're going to encounter a nurse. And as Barrett says, there are many different kinds of nurses from starting out in the community through our Cancer Care Equity Program. We have nurses that work with our lay navigators to educate and outreach to our vulnerable communities to support health promotion activities, help patients in different communities get in for screenings and so on. And then in the hospital, probably the majority of our nurses are delivering direct patient care in the hospital, around the clock, or in the infusion areas, treating patients that are actually with us in an active treatment. And we also have nurses that are, we call hospital-based navigators, oncology nurse navigators, that are coordinating care, all the tests, all the different steps to care and treatment that a patient and their loved one will experience. And all the while, you know, thinking about and holding that patient through and their loved ones through the whole experience of cancer treatment. We also have nurses that are very specialized in working with our investigators on clinical trials. And so that is a huge responsibility for nurses very specially trained in how to conduct research in a trial and how to keep a patient safe from the beginning of the time that they enter and enroll in the trial until they complete treatment. And so they're constantly with that patient assessing them for symptoms and side effects and ultimately toxicities if that were to happen. And so really supporting patients through drug trials. And then finally, we have a Center for Nursing and Patient Care Services Research where we have nurse scientists who are conducting original research and thinking again about what are nurses interested in. We're interested in, and our nurse scientists are interested in symptom science, and a lot of what they study has to do with understanding what, as the field changes and new modalities for treatment are coming forward, what are the symptoms and side effects that patients are going to experience, and how do we intervene and understand why some patients experience some symptoms and others don't. And they're involved in a lot of quality of life studies too, how to ensure the best quality of life for our patients through treatment.
And you might let the audience know about, briefly, some of the challenges that nurses who do original research face at Dana-Farber.
Well, in fact, there are some challenges, although we have grown. We are the largest center for nursing research in any cancer center in the country. But you're right, like other investigators, we struggle for funding and to get our studies funded. Probably the biggest thing that we're working on now relates to the fact that Harvard University does not have a College of Nursing associated with it. So we partner with a number of universities in the city, but we're really looking now to consider how to develop a stronger partnership with a single university so that our nurse scientists can also hold faculty positions and progress academically in a College of Nursing.
Yeah, that's something that we really, at the Institute, we really support. And I, as the academic dean for Dana-Farber, I have this Harvard thing looking over my shoulder, but I think we really need to support our nursing faculty as they look at academic positions. So thank you for that. Karen, so we've heard from the moment people walked in here about the incredible advances that are being made in treating cancer and understanding cancer. And as wonderful as all that is, we know that the burden of cancer is still disproportionately supported, felt, impacted by individuals from traditionally marginalized populations. This is something that you work on not only within Dana-Farber, but within DFHCC. Maybe you could talk a little bit about things like the Navigator program and others, where we try to get a more equitable sort of distribution of our advances.
Thank you, Barrett, for the question, and it's really important and key, and allow me to reference my notes. The concept and model of patient navigation really is what we like to refer to as the rapid response, which allows you to assess, identify, and address barriers which could impede one's treatment and care planning process. It was Dr. Harold Freeman, a surgeon at a Harlem hospital back in 1990, who very quickly noticed that individuals from marginalized communities really had better outcomes when we address not only the cancer care, but we approach the patient through a holistic lens and not just the disease. So when we think about the news of a cancer diagnosis, it's significant for everyone. And once getting over the initial shock of having cancer, the wheels are in fact put into motion. But for some, when that cancer diagnosis is revealed, the process of seeking treatment may not be their immediate priority. Before the conversation of even care planning or including the who, what, the where, there are more pressing matters that might need to be addressed. Could include things such as financial constraints, How am I going to hold on to my job? What about health insurance? Yes, I have it, but will there be any out-of-pocket costs? And even things such as transportation, right? Maybe the plan of care could include daily radiation or chemotherapy visits. How in the world am I going to make this happen? And so in 2022, under the leadership of Dr. Chris Lathan, Dana-Farber's Chief Clinical Access and Equity Officer, there was a centralized patient navigation system that was developed and successfully implemented for adult patients, primarily from Dana-Farber Cancer Institute priority neighborhoods, which include Dorchester, Mattapan, Roxbury, and Jamaica Plain. And the patient navigators at Dana-Farber, they are members of the interdisciplinary team, and they serve in the capacity of proactively identifying, even before patients come on board or come in for a visit, they look to remove any obstacles that could in fact get in the way. So patients are contacted prior to their first visit. They are, if resources are needed prior to coming in, and it could be the situation where there are community resources that could help in this regard. But quite often, these navigators are able to contribute information to the overall care planning team that may not be revealed if it wasn't for having these intimate conversations. And so we are really thankful and grateful for the generous giving to allow this program to be launched. We're grateful that navigators are currently embedded in 4 different disease areas. And we're grateful that we're looking forward to expanding where our navigators currently serve and looking to move to the hematologic malignancies area. And so, again, the end goal, right, is that everyone has access, that we're looking to advance health equity. We want to level the playing field in this space. And we're looking to not only level the playing field, but reduce no-show rates, increase adherence to treatment, as well as ensure the supportive use of, supportive utilization of supportive services at Dana-Farber.
That's so helpful, Karen. A great picture of where our problems are in terms of equity. But I'm going to stick with you for a second because you've talked about access to healthcare, but there's another access issue that you've spent a lot of time working on, and that means a lot to me. I've actually participated in your programs occasionally, and that's access to training and education. One of the problems that Dana-Farber faces is the underrepresentation of individuals in our faculty and in leadership positions. And what we constantly come up against is the pipeline problem. Individuals from underrepresented communities who have not been able to get into the pipeline to get to the point where we can recruit them to our faculty or our staff and so on. So maybe you can talk a little bit about the things you've done around improving that access.
So Barrett knows that my sweet spot in having been at Dana-Farber for many of years is what I call the continuing umbrella of research experiences, the CURE program. The CURE program is a research program that exposes underrepresented students from high school, undergraduate students, as well as post-baccalaureate students to the field of cancer research. It gives individuals this early exposure, puts them in environments where they thought or they never would have thought that they could in fact be in. It's a program that operates, we have multiple tracks, we have a 2.5-year program, we have a summer-only program, but to be able to see firsthand these individuals participate in research, be able to communicate their research and be part of a research team is so very remarkable. Additionally, through the leadership of Candace Burns, who heads up the Workforce Development Department, there are other programs. There are adult programs. She has 9 pipeline programs that affords individuals from surrounding communities and even from within Dana-Farber, opportunities to finish their degrees, opportunities to engage in clinical research management. We've had problems with regards to having enough individuals to manage our clinical trial system. Now we have a clinical research pipeline that allows for individuals to be trained in that space. And again, the importance of all of these programs is that it allows for our workforce to be better prepared, but provide the necessary exposure for individuals to, in fact, assist in areas that they may not have had the opportunity to be part of.
Yeah, so back when I was running a lab, I had a couple Cure students in the lab, so I'm a satisfied customer. It's really a great program, and you've had amazing successes. There are individuals who are in the biotech industry, gone on to get PhDs, that might not have otherwise done so. So I think it's a real success story. But speaking of that pipeline, Anne, so people may have read in the newspaper, seen news reports about the fact immediately after the pandemic, there's been an incredible shortage of nurses. And I've seen some statistics or some projections that suggest the nursing shortage may last for another decade, which is pretty frightening if you think about it. So I'd like to hear your opinions about the nursing shortage and the kind of things that you're thinking of doing at Dana-Farber to help address this.
Sure. Well, the nursing shortage actually that we're in right now was really predicted before the pandemic. The pandemic exacerbated it and made it even bigger than it is. But you know, there are a lot of reasons for that. But we started planning at Dana-Farber back in 2015. I think we conceived of and started our first newly licensed nurse residency program, and that was with the support. Dr. Glimcher was, and others in the institute, very supportive of us testing this concept. You know, we don't get federal funding in nursing for training after graduation. And you can't graduate from colleges of nursing today and come into a clinical environment like Dana-Farber and practice. The learning curve is just too great. So we piloted this concept, and it's now a very robust, incredibly competitive residency program that's grown with funding, continued funding from many sources, several very wonderful donors that have really supported us in training the next generation. We've done it in partnership with the University of Massachusetts, Boston. We're very committed to, along with training the next generation in that pipeline, really trying to attract a more diverse population to the profession. And interestingly, just as you heard about Karen describe the CURE program, one of our residents about 3 years ago was a graduate of the CURE program that went on to finish school and then worked in a lab at Dana-Farber, but decided she wanted to go to nursing school. And so we supported her, and now she's a nurse working in one of our the patient care units. So it really, it's such a powerful example about how far upstream we need to start in building these pipeline programs, but how successful they can be if with dedicated resources.
Yeah, so you've talked about the importance of training, specific training around oncology for oncology nurses. Maybe you could take a step back and say a few words about the importance of an oncology-trained nurse in the actual care of an oncology patient. Why should we care about that?
It's very important to care about that because nurses are, they're nurses that are specialized in many different areas, but healthcare has become so complex, and certainly our field is so complex that to have a nurse that, in our setting, where our nurses they're not just trained generally in oncology, they're trained very specifically about what are all the aspects of breast cancer that a patient, would be coming to us that would have needs around, and how can they, and all of the interventions that go along with supporting a patient through treatment. And so you don't have that expertise if you can't specialize. And so, and that time to become specialized needs to be carved out of a regular work environment to a learning environment, which we have been able to do with our residency program. And it really is critical, and it's one of the wonderful things that we look forward to as we build our cancer-only hospital, that every single patient taken care of in our beds will be cared for by oncology-trained nurses.
See how I set you up for that?
You did. I just loved it. I didn't even know you were going to do that.
Unbelievable.
So, Tony, you've been uncharacteristically quiet.
18 minutes left, all for me.
All for you. So, I know in the last session, Bill talked a lot about collaboration. But I'd like you to talk about collaboration from the point of view of somebody who does trials, who works. I think you are one of the most efficient and effective people who works with our scientists, laboratory scientists who don't necessarily do clinical trials. Talk a little bit about that and where those collaborations go and why they're so important to what you do.
I mean, that will take 18 hours, not 18 minutes. But let me start by what you asked me first. These industry-sponsored large trials and the investigator-sponsored trials, and I'll give you an example from people in the room, okay? So I start working with Bill Kaelin since I came here. You probably know Bill Kaelin, 2019 Nobel Prize.
Yeah, but what has he done lately?
So because that's how I talk to Bill. It's like, so, but this patient of mine is not responding, and it's your fault. Sure. In medicine or physiology, although he may get something else in the same group at some point. So we started working, Bill was working on a protein called VEGF that drives what we call the angiogenesis, tumor growth through blood vessel that feed the tumor. It's another way about it. And kidney cancer is the treatment, is the example, the poster child of this, not as much other malignancy, and that led to the approval of many drugs. But Bill also at the same time, was working, targeting another protein, a different protein, a transcription factor, what means for all of us, this is or at least some of us, protein that is hard to target. There's a lot of protein in the body, bad ones, but hard to target, but was able, him and another team, to target HIF2, and that and other were the base of the Nobel Prize in 2019. And, Bill and I started with a startup that was a spin-off, and little by little there were drugs, and the drugs, we did it a phase 1 study first in a human funded by the company, and it showed in a refractory patient, a very hard to treat patient with kidney cancer, responses around 20–30%, and overnight, there's another famous company by the name Merck that came and took overnight. It happened overnight, and now Merck is able to do a hundreds of million-dollar trials, and we did the trial, Bill was involved, in 25 countries, 300 sites in the world, and I just landed yesterday at noon from Madrid because we were presenting that trial of 800 patients that I think is going to lead to the approval to the drug. So that was an example how we work from A to Z to industry. Now let me tell you another example of another dear friend of mine here, Kathy Wu. Kathy has worked nonstop in cancer immunology on cancer vaccine. And I remember when I trained in Cleveland, I'm from the Midwest, that's not a Saudi accent, by the way. Yeah, too. Yeah, Cleveland, another Cleveland Browns fan. Sorry, I shouldn't have said that in Boston.
It's fine.
Is anyone from
this year? It's fine.
Anyone from, okay. Anyone from the Kraft family? No. Okay. No. I just don't want to get in trouble. So, we work with Kathy Wu on a cancer vaccine. When I'm trained in Cleveland, when I go for advice, and they tell me two things. Anything you want to do in GU, there are two things you cannot do. One, radiation, and second, cancer vaccine. So of course, what Dana-Farber does is what people cannot do and are not willing to do, and even teach some generation not to do. Kathy has been working on that. We just recently finished first in a human trial, an investigator-sponsored trial. When you tell me about investigator-sponsored trial, that's a trial that did not have money. Kathy and I had to write, and several others in the room here, Patrick Ott, Ed Fritsch, other, had to write grants to the Department of Defense and other, and we finished trial of 14 patients. We didn't have any cancer that came back after resection, and the paper is in review. And this is another example how we all can work together. So I gave you an example about one with Dr. Kalin that led to an industry responder, another one that led also to a trial. Both we work, again, like you said, the patient at the center. It doesn't matter how and how hard it is.
Yeah, it's great. And I'll just add that our collaborations go much farther than that. So many of you know about our Profile program, which gets DNA sequence information on the cancers and leukemias of all the patients who come to Dana-Farber. We, right from the beginning, shared all of those data with what is now a 35-hospital consortium around the world, which is sponsored by the American Association for Cancer Research. It's called Project Genie. And we were just ready to give that data out and make sure that everybody could share it with some rules around it, but it's available publicly. And that sort of, again, goes against this notion that people are just not talking to each other. We talk to each other all the time, as Bill pointed out. So that's another great example, I think.
Absolutely.
Okay, so I'm going to end up the same way that the other group ended up. I'm going to ask each of you, what's next? This session is about innovation. What's next? What's new? What's around the corner? What's the thing you're most excited about that's going to happen in the next year or two? And because Tony's vocal cords are all warmed up, I'm going to ask Tony first.
I don't want to talk just about like the cancer prevention, the vaccine, the work that Ellie Van Allen is doing, first of its kind in AI and oncology. I want to just talk how excited about the international collaboration that Dana-Farber is having. It's different than other centers. We're not going to a place, let's say, in Brazil or in Canada and build a hospital. No, we are trying to train the folks there outside. So I give an example of the largest practice in Latin America in Brazil, of 600-700 oncologists that is by the name Oncoclínicas, and how we're training them, not just in oncology, and they come, but in leadership, in pharmacy, in nursing, in tumor board, in precision oncology, to have another perhaps branch in a way there too. I'm excited about that, how it's evolving. I'm also excited about the international academic collaboration. We talked about Gustave Roussy in France. That's at least ranked by Newsweek, the first cancer center in Europe. Ahead of us. I don't understand how the French can be, but that's okay. And we did several conferences back and forth with their top people. Dr. Van Allen and I were in Paris last week, part of the exchanges. I'm very excited about that, and we're warming up.
Plus, you get to go to Brazil and Paris.
Right, and accumulate miles.
Yeah, it's not a bad gig, right? Anne?
Well, I'm excited about a lot of things, but I think in the forefront right now for me is our new hospital. And I'm both excited and terrified because we'll be recruiting about 800 nurses over the next many years, and we have to find them.
You're going to interview each one.
But I think there are many ways, and we have so much potential right here inside Dana-Farber, and was just talking to some of my colleagues at the break about the kind of next frontier for building the pipeline is we have a number of employees right here at Dana-Farber who work as clinical assistants and in other entry-level jobs who have incredible dreams and career aspirations that they haven't had the opportunity to pursue because they don't have the funding, they have a lot of juggling, a lot of competing demands, and yet those dreams and aspirations are there, and I think we have recently received a little bit of funding to prove this concept, to provide tuition scholarships for clinical assistants that are interested in careers in healthcare, and I really want to do more of it. And I think we're at a time in Dana-Farber history where there is a tremendous commitment to this, and I think we can really make a lot of progress.
Yeah, thank you. I mean, 800 nurses is a very daunting number, but thanks to what you've done, I think these end up being really attractive jobs. So I don't think it's going to be that hard.
Well,
right?
Thank you for your vote of confidence.
Yeah, well, don't come to me if you have Karen?
Thank you, Barrett. So, on the patient navigation front, there's no reason why every single patient from our priority neighborhoods cannot have a patient navigator, no matter what their disease of cancer is. And so we want to expedite getting navigators into all of our disease centers. So that's number one. And we want our patients to know that they are in fact welcome, and that no matter what their disease is, we will be there to look at them as a whole patient, right? We don't want them to worry about childcare, and we don't want them to worry about how are they going to manage getting back and forth. We want them to worry about getting through their cancer journey and not these other factors. And then secondly, on the training front, ideally, I want every single research environment, whether it's in nursing, whether it's on the basic science front, or even within clinical research, to be open to having a student under their wing so that they can learn and get this early exposure and recognize that it does in fact matter, and their input matters, and their diversity of thought matters, right? In addition, I think it's really important to look at developing new collaborations. We've started having some conversations with historically Black colleges and universities, and really trying to gain their insight and their input into coming into the Boston area, right? And being able to have these kinds of experiences within our research front. So I think that all of these things are definitely doable. And with donors such as yourself, that we can make these things happen.
That's fantastic. So it's been a real privilege to share the stage with you. You've given us, just incredibly inspiring visions for the future, and I'm sure they're all going to come to fruition. So thank you again very much. Steve, I think you're back up again.
Thank you. You're so cute.
Wow, that was inspirational. Earlier in the day, David Nathan had a little bit to say about his time here, and he taught all of us who care for the children something that sticks with me when I think about it and listen to Ann and Karen. In the morning when you start and before you leave in the evening, if you want to know how the patient is, you ask the nurse who has spent hours with that individual with whom you have spent minutes. And that's just reality. And I think it's what makes them so special. So special to me that I married one and have a daughter who's one at the Dana-Farber. So I hope you've been inspired. I mean, it always seems to me that the most important thing for sort of a committed donor community to have is a sense of, what they got for their investment. People want to know, what do you need? Okay, here it is, and tell me later what you got. And hopefully you've had enough examples of that today to inspire you and to keep you fully engaged till we do this again next time. So the program continues. There is a reception that will be, I'm told these doors will open over on this side now. Please stay, enjoy the reception. I know several of you had signed up for some dinners afterward. They start at 7. The reception starts right now. Thank you all very much.